Hello, fellow sapiens, and a warm welcome to Midnight Sapien. Whether you're drifting off beneath a weighted blanket, passing time on a midnight drive, or quietly preparing for sleep with the curtains drawn, this space is for you. Because tonight, we journey into the mysterious cold that interrupted the dawn of civilization. This is deep-time storytelling for minds that move slowly, curiously, an untold story of the Younger Dryas, a 13,000-year-old freeze whispered through layers of silence and ice. But this is not a tale of slow glaciation, it's one of sudden reversal, of a planet that warmed, then stopped, not to perish, but perhaps to protect itself. And, if you're someone who enjoys long-form storytelling, rich in science and silence, look just below the video. There's a button there that says subscribe. Tap or press it if you'd like. You can unsubscribe anytime. And there's a little bell next to it too. Tap that, and you'll know when the next story arrives. Your support helps this channel survive. Midnight Sapien depends on subscribers to keep making these quiet films. I wonder, where are you listening from? What time is it for you right now? If you feel like sharing, write it in the comments. It's a gentle reminder that we're all listening together across the map. Oh, and if sleep comes, let it. You'll find chapters and timestamps down below. We begin with the echo in the ice. What happens when a planet that has finally begun to thaw suddenly freezes again? This is the mystery at the heart of the Younger Dryas, a climactic twist in Earth's long and tangled story. For over 10,000 years, glaciers had slowly receded, meltwaters had begun to swell the rivers, and fragile warmth had returned to the northern hemisphere. But just as the ice seemed to surrender, just as the stage was set for rebirth, the world turned back. In less than a human lifetime, the Earth cooled, abruptly, violently, without warning. The air thickened with cold. Seasons lost their rhythm. What had once been the slow blossoming of spring became again the silence of winter. Why would a planet do such a thing? Could a living system, ancient, vast, and self-regulating, choose to freeze itself just to survive? 12,800 years ago, the story of the Earth veered off course. The warmth that had been building for millennia halted like a breath caught in the chest. Average temperatures plummeted across the northern hemisphere, some regions dropping by as much as 10 degrees Celsius within a decade. In Europe, birch forests died where they stood, unable to adjust. Glacial fronts advanced once more across Canada, their icy walls dragging wind and time behind them. In the Levant, young settlements that had only just begun to experiment with cultivation found themselves surrounded by a cold, brittle world that seemed to retract its promise of progress. And still today, when we dig into ancient sediment, when we measure the gases trapped in old ice, we find the same moment recorded across continents, as if the entire planet shivered and remembered. But what was this place that froze so suddenly? To understand the chill, we must first feel the thaw. Before the Younger Dryas began, the Earth had been emerging, hesitantly, imperfectly, from the long grip of the Pleistocene. It was a world still haunted by giants. Mammoths roamed the grassy steppes of Eurasia, grinding the soil beneath their heavy feet. Mastodons shouldered through North American pine forests. Saber-toothed cats and cave lions stalked herds across windswept plains. The great glaciers, which had once sprawled like sleeping gods across entire continents, were now in slow retreat. And in their wake, new landscapes emerged, rivers carving out valleys from forgotten ice, wetlands teeming with early life, and clouds of pollen carried by winds that finally blew warm. Human beings, too, had begun to move differently. In pockets of the Fertile Crescent, small groups were shifting from wandering to tending, observing the rhythms of barley, storing the pulses of lentils, shaping stone into tools not only for the hunt, but for the home. In the Americas, the Clovis people left behind their precise fluted spear points, testaments to the hunt and to the deep understanding of the land. Across the globe, the great experiment of civilization had not yet begun, but its ingredients were forming. What must it have felt like to stand on that edge of transformation? And then, the warmth vanished. The sky darkened with a silence no storm could explain. Rivers slowed, forests failed to bloom. Within the span of mere decades, far less than a human lifetime, Earth's northern latitudes collapsed back into cold. The change was not gentle, it was not generational, it was sharp, sudden and planetary. This was the onset of the Younger Dryas, a name that now haunts the geological record like an aftershock of forgotten memory. Named after the mountain avens, a hardy Arctic flower that suddenly returned to Europe's fossil pollen record, the Younger Dryas marks a climate whiplash unlike anything we had known. For 1,000 years the world reversed its path. It chose, inexplicably, to freeze again. But what force could compel the atmosphere itself to retreat into ice? Scientists today trace the fingerprints across many places in the oxygen isotopes of Greenland's ice cores, where a sharp decline in temperature leaves a jagged scar in the data, in the layered sediments of lake beds, where seasonal rhythms give way to chaos, in the loess of China, the dust of the wind, where the pattern of the monsoon abruptly changes direction. Each record tells the same story. A planet that was healing, suddenly sickened. But there is no singular wound, no simple answer. Just a tangle of signs and symptoms, like a body responding to a trauma whose source remains unclear. One of the most widely accepted theories proposes that the source of this shock lay not in the sky, but in the melting veins of the Earth itself. As the glaciers of North America melted, they fed colossal volumes of fresh water into vast inland lakes. One of these, glacial Lake Agassiz, was larger than all of the Great Lakes combined. It sat like a silent ocean on the spine of the continent, restrained only by ridges of ice and land, and then, suddenly it emptied. Whether through gradual overflow or catastrophic breach, an unimaginable torrent of fresh water surged into the North Atlantic. The ocean's great conveyor belt, the thermohaline circulation that pulls warm water northward and drives weather across the globe, was disrupted. Like a heart thrown into arrhythmia, the climate convulsed. But is that explanation enough? Could a single pulse of fresh water truly chill the world? Or are we missing something more subtle? Something more cosmic? What if the freeze was not merely a symptom, but a decision? What if Earth itself, in some strange act of self-preservation, initiated a shutdown to prevent a greater collapse? Across continents, the effects were immediate. In the Near East, archaeological layers show settlements abandoned, crops failing, populations dispersing. In northern Europe, tundra plants reclaimed forests. In the Americas, once abundant megafauna began to vanish from the record. The forests grew quiet, and the bones grew common. Was this extinction or evacuation? And in the midst of this turning, where did humanity stand? We stood between worlds. On one side, the Pleistocene, the age of great beasts of glacial breath, of hunter and prey locked in ancient balance. On the other, the slow emergence of something new, permanence, memory, settlement. But the Younger Dryas carved a ravine through that passage. It forced our ancestors to reckon not just with survival, but with interruption. The rhythms they had begun to trust, of seasonal rains, of animal migrations, of edible roots and steady warmth, broke apart like ice underfoot. Can we imagine that kind of silence? The silence of waiting for spring and finding only more snow. This was no mere inconvenience. For early humans whose lives were attuned to the subtlest cues in nature, the budding of certain plants, the shifting winds, the thickness of animal coats, such a disruption was existential. In places like Abu Huraira, a site along the Euphrates River, archaeologists find evidence of a people transitioning from foraging to farming. But that story is jagged. It is not a gentle curve of progress. Instead, we find bones crushed from overwork, teeth worn from grinding wild grains, layers of ash from abandoned hearths. The cold did not just freeze the rivers, it reshaped the very course of human adaptation. Were we pushed toward agriculture by the need to survive a world that had turned unstable, and as we turned inward, many of the creatures we once lived alongside disappeared. This is the shadow cast by the Younger Dryas that still lingers today, the twilight of the megafauna. Mammoths that had walked beside us for tens of thousands of years vanished from the plains. The woolly rhinoceros fell silent. Giant sloths, cave bears, glyptodons, and saber-toothed cats disappeared from the fossil record like characters removed from a play. Across Eurasia and the Americas, the great tapestry of animal life unravelled. In some regions, over 70% of large animal species went extinct. What could have driven such a sudden silence? Was it the chill that took them, or was it us? Some argue that human overhunting played the final decisive role. Others claim the cold tipped delicate ecosystems into collapse, and some still suggest a darker possibility, that something more sudden, more violent struck from above or surged from within, setting off a chain of events neither beast nor human could endure. But beneath all these debates lies a deeper question. Why did the world change so quickly, and why did it choose to take so much with it? It is here, in the overlapping mysteries of ice and extinction, that we begin to glimpse the fragility of progress. The Younger Dryas was not a distant weather pattern. It was a planetary decision felt in every breath, every step, every fire lit against the dark. And for those early people, with no words for climate or system, only the daily struggle to endure, how was meaning preserved? What happens to memory when the world forgets its rhythm? Perhaps it becomes myth. Perhaps it sinks into symbol. When the cycles of nature no longer align with the stories passed down by firelight, a rupture opens, not just in climate, but in culture. And yet, we survived. Across the continents, small bands of humans adapted in ways we are only beginning to understand. In Anatolia and the Levant, where early attempts at sedentary life were faltering, some groups returned to the nomadic paths of their ancestors, following the pulse of dwindling game. Others, remarkably, persisted in place, engineering new techniques for grinding wild cereals, storing roots, digging into the earth for warmth. Was this the moment endurance became ingenuity? In North America, the Clovis people, once believed to be the earliest human inhabitants of the continent, left behind a trail of beautifully worked stone points, scattered like echoes across the open plains. Their tools appear suddenly in the archaeological record, then disappear just as quickly during the onset of the Younger Dryas. The reasons remain uncertain. Did they perish with the mammoths they hunted? Did their traditions fragment into new cultures, no longer tied to a single signature of stone? Or did the freeze force a forgetting, a recalibration so complete that even identity was reshaped? There is something haunting in this quiet vanishing, not just of people, but of ways of being. The world that had begun to soften, lush with green, alive with creatures suggestive of permanence, froze again into impermanence. The places where early farming had begun now demanded foraging once more. The places where animals had once thrived grew still, and in the midst of that humans were asked a question by the planet itself. Can you adapt to a world that forgets its promise? In the Andes there is evidence that highland dwellers began storing food underground, potatoes and tubers buried like treasure beneath frost-bitten soil. In northern Japan, hunter-fisher communities shifted from inland rivers to coastal zones, tracking fish migrations altered by colder currents. Across Siberia, the persistence of flint tools suggests not regression, but conservation, a choice to hold on to technologies that worked under the new, brittle regime. Adaptation, in this sense, was not innovation for its own sake. It was a form of memory. It was continuity disguised as change. And yet, what do we do with the grief embedded in this resilience? The loss of the great animals, the retreat of warmth, the abandonment of settlement. For those who lived through this shift, it was not a line in a textbook. It was hunger. It was uncertainty. It was an entire generation born into cold, with no knowledge that the earth had once opened to them in bloom. How do you explain to your children that the world used to be softer? What kind of stories are born? When the earth stops growing things, perhaps the oldest kind, stories of punishment and cycles, of gods displeased, of suns dimmed, of fires stolen and skies cracked open. When crops fail and animals vanish, when snow falls in seasons it does not belong, people reach for meaning. And in these moments, when nature behaves as though remembering some older command, myth and memory intertwine. Is it possible that the great flood myths, the tales of sudden fire or world reformation that appear across dozens of ancient cultures, are echoes of this deep planetary trauma? Not fabrications, but distorted recollections, passed from shivering mother to curious child, through centuries of oral transmission. The Younger Dryas is not only recorded in ice cores and pollen diagrams, it may be preserved in the architecture of remembrance itself. Sites like Göbekli Tepe, erected not long after the return of warmth, stand as monuments to something remembered, or perhaps something feared. massive T-shaped pillars carved with animals now extinct, gazing outward with watchful silence. It is as if the builders were trying to preserve a world they knew was slipping away, a mausoleum of memory set in stone. What do you build when the world has betrayed you? And yet, the cold did not last forever. After nearly 1,000 years, the Younger Dryas ended just as abruptly as it began. Temperatures rose, ice retreated, forests returned. But the memory remained, embedded in soil layers, frozen in glaciers, imprinted in the bones of extinct animals and the genomes of those who survived. It is a memory not just of a climate anomaly, but of an existential threshold. The moment the Earth, once warming, chose instead to pause, to inhale, to delay its rebirth. Why? This is the question that has haunted scientists, archaeologists, climatologists, and storytellers alike. Why would a planet emerging from cold slip back into it? Some say it was an accident of timing, a convergence of melting ice and ocean currents. Others speak of impact, of cosmic debris disrupting the sky. And a few still wonder if the planet itself, complex, self-regulating, alive in ways we barely comprehend, triggered the freeze as a form of balance, as if on the brink of too much warmth it intervened. Could Earth protect itself? We are left with fragments, charcoal in distant layers, broken bones, isotopic shifts, vanished animals, abandoned hearths, and yet from these remnants a story emerges, not a tidy one, not one with villains or heroes, but one with lessons about resilience, about forgetting and remembering, about the silence that follows disruption, and the growth that may follow silence. So when we ask if Earth froze to save itself, we're also asking something more human. Can survival be a kind of wisdom? Can absence be a message? Can cold be an act of care? These are questions we carry forward, like embers cupped in our hands. Because the Younger Dryas is not just behind us. It lingers in climate models, in ancient myths, and in the quiet recognition that the world we live in can change its mind. The world had frozen when it was meant to thaw, and the question would not let go. Long after the glaciers had receded for the final time, long after the mammoths were gone and fields had given way to grain, the Younger Dryas remained. Like an echo suspended in ice, it haunted the layers of Earth with its inexplicable brevity and violence. Scientists and storytellers alike would return to it again and again, compelled not only by its mystery, but by its refusal to behave like anything else in the climate archive. What kind of event could slam the brakes on a planet's warming in less than a decade? What force could turn the course of time backwards? The first clues emerged not from epic discoveries, but from quiet patterns. In the mid-20th century, as ice core sampling and sediment analysis became more refined, paleoclimatologists began to see something strange. In Greenland's ice, they noticed a sudden drop in oxygen isotope ratios, an unmistakable marker of a rapid cooling. It wasn't a soft curve, but a cliff, a plunge. And as cores were pulled from lakes in North America and peat bogs in Europe, a matching signal appeared in pollen records and dust concentrations. Something had changed, globally, and almost simultaneously. But it wasn't until the analysis of radiocarbon dating grew more precise that a narrative began to take shape. The anomalous cooling event centered around 12,800 years ago didn't seem to fade in or out gradually. It had an edge, a beginning that snapped into place, and an end that felt almost as sudden, and so it needed a name. Botanists found it first in floral remains across Europe, the sudden return of a hardy Arctic plant, the mountain avens Dryas octopetala. Its presence in abundance signalled a reversion to tundra conditions, a floral alarm bell ringing through the layers. From this came the name, the Younger Dryas. To name something is to accept its reality. And once the Younger Dryas was named, it could no longer be ignored. It became a feature of Earth's climatic past that demanded explanation, not just observation. Theories emerged in cautious tones. Some researchers believed it was linked to the final stages of the last ice age. Perhaps the collapse of glacial structures had released vast volumes of cold freshwater into the Atlantic. This freshwater would have disrupted the thermohaline circulation, the deep ocean current that acts as the planet's heat conveyor. Without the northward pull of warm equatorial water, Europe and much of North America would have cooled dramatically. But was this theory enough to account for such speed? For such scale? And why did the Earth seem to snap back to warmth just as sharply 1,000 years later? This was not the behaviour of a slow-moving climate machine. It was the twitch of something more alive, more volatile, a system that could convulse, reset, and resume. For the researchers piecing together the climate's long history, this was unsettling. It suggested not just feedback, but thresholds, tipping points hidden within the ordinary rhythm of weather, thresholds that once crossed could unleash sudden planetary shifts. What else might lurk beneath the surface of the Earth's calm? The theory of meltwater pulses began to grow in sophistication. Scientists proposed that the rapid collapse of ice dams, particularly from glacial Lake Agassiz, could have released massive torrents of fresh water into the North Atlantic. This sudden influx would dilute the ocean's salt content, interrupting the thermohaline conveyor and plunging the northern hemisphere into a deep freeze. But still, there was a problem. The ocean is not a simple switch. It is vast, layered, and buffered by inertia. Could even this much fresh water truly grind it to a halt? Could it stay halted for a millennium? Paleoclimatologists began to search for supporting evidence in the sediments of ocean floors. There, they found dropstones, large chunks of rock carried by icebergs that had floated farther south than normal before melting. Their presence suggested the ocean was not only colder, but clogged with drifting ice. It seemed to match, but not everyone agreed. Some datasets failed to align, some sites showed cooling earlier or later than others, and some, curiously, hinted at events that did not fit within the meltwater framework at all. Like what? Like fire. In the dark layers of soil found across multiple continents, researchers began to detect high concentrations of soot, microscopic carbon spherules, and even platinum anomalies. These were signatures not of water, but of combustion. Charcoal in abundance, burned vegetation, traces of metals rarely found in natural quantities on Earth's surface. What kind of fire burned so widely, across such distances all at once? A new theory was born, not from oceanography but from the sky. The Younger Dryas impact hypothesis, proposed in the early 2000s, argued that the event may have been triggered not by terrestrial processes, but by an atmospheric cataclysm. According to this idea, fragments of a disintegrating comet struck Earth, or exploded in the upper atmosphere, releasing immense energy across North America and potentially other regions. The resulting shockwaves, wildfires, and atmospheric debris would have darkened the skies, cooled the surface, and collapsed ecosystems. Could this explain the extinction of the megafauna, the vanishing of the Clovis people, the sudden black mat layers that appear at sites from California to Syria? Yet the idea remains controversial. Impact hypotheses stir emotions. They promise drama but require precision, and the evidence, though intriguing, is debated. Not all scientists agree on the interpretation of microspherules, or whether the platinum anomalies are from space at all. But even skepticism cannot erase the core truth that remains. The Younger Dryas does not behave like an ordinary climate fluctuation. It erupts into the paleoclimate record like a cry, sudden and discordant. It lasts for 1,000 years, a heartbeat in geological time, and then ends without warning. Such behaviour unsettles the foundations of gradualist thinking. The belief that change always unfolds slowly, predictably, over epochs. Here, in the middle of Earth's great warming, the planet reversed itself. The glaciers paused their retreat, forests withered, sea level steadied, and then, just as abruptly, it began again. How do we explain an intermission in planetary transformation? For some, the answer still lies beneath the surface. New research into glacial hydraulics has proposed that repeated meltwater pulses, not just one, may have occurred over centuries, releasing waves of fresh water into the Atlantic like rhythmic aftershocks. In this version, the thermohaline circulation did not collapse all at once, but staggered, weakened, and oscillated between states of activity and dormancy. A planet caught in a kind of climatic limbo, unable to proceed forward or return fully to the past. Is this not the very definition of a threshold? And still, the fire persists in the background. The black mats, the mysterious layers of dark, carbon-rich soil, appear at dozens of archaeological and geological sites around the world, all dating to the onset of the Younger Dryas. In some locations, these mats are accompanied by tiny magnetic spherules, nanodiamonds and melt glass, all materials that hint at extreme heat and rapid cooling. Some of these clues suggest temperatures reaching thousands of degrees, but how do you start a fire that hot without a flame from above? Proponents of the impact theory point to the torrid meteor stream, a debris field left by a giant comet that entered the inner solar system thousands of years ago. Earth still passes through it today, a gentle drizzle of shooting stars. But was it once more violent? If a large fragment exploded over the ice sheets or impacted directly, the effects could have been catastrophic, melting glaciers instantly, vaporizing biomass, and sending plumes of dust and aerosols into the stratosphere. Such a blast might trigger precisely the kind of cooling the Younger Dryas exhibits. But how do you prove what no one saw? Skeptics counter that there are no craters, no definitive impact sites. And yet supporters respond, if the comet fragmented in the atmosphere, it might not leave a crater at all. Only burned soil, scattered debris, and a chilling shadow over the Earth. So the evidence remains partial, ambiguous, disputed, a forensic scene without a weapon, a crime without a body. And here, the mood begins to shift. Scientists accustomed to reading the slow language of ice find themselves surrounded by noise, by anomalies, contradictions, missing data points. The models do not agree. The timelines blur. The Earth's behaviour, usually so patient and mathematical, becomes erratic, chaotic. Was the Younger Dryas an accident or a message? This is where the investigation takes on its philosophical weight. For if Earth can change so rapidly, so radically, without obvious cause, then our understanding of climate must make space for uncertainty, for events that defy the slow arcs of prediction. It is not just a question of mechanism, but of meaning. What kind of planet are we living on, if it can shudder into cold, stall its own warming, and then resume as though nothing happened? Are we witnessing a malfunction or a form of regulation? In the late 20th century, a new concept emerged in Earth science, the Gaia hypothesis. Proposed by James Lovelock and Lynn Margulis, it suggested that Earth functions not merely as a host of life, but as a self-regulating organism, a living system with feedback loops that maintain equilibrium. It was a metaphor at first, but over time, it began to shape real scientific inquiry. Could the sudden onset of the Younger Dryas be viewed not just as a disruption, but as an immune response, a planetary correction? Consider this. If the Earth's warming trend threatened to destabilize ice sheets too quickly, leading to catastrophic sea level rise, a temporary refreeze might buy time. If ecosystems were shifting too fast, if atmospheric chemistry was changing too abruptly, a cold pause might act as a stabilizer. Is it possible the Earth, through a confluence of factors, triggered its own reset? This idea remains provocative, even fringe, in the formal literature, but it invites a deeper contemplation of complexity. In systems with many moving parts, oceans, forests, clouds, polar ice, biospheres, emergent behaviours can arise. Behaviours not dictated by any one part, but born of the interaction between all parts. What if the Younger Dryas was not the result of a single event, but a cascade, a domino sequence of meltwater, ocean disruption, atmospheric shifts, perhaps even extraterrestrial input, converging into a moment that could not be avoided? In this view, the search for a singular cause becomes less important than understanding the threshold itself. What happens when the system reaches its limit? What does the Earth do when nudged too far? In the language of chaos theory, this is the butterfly's wing, a small perturbation triggering a global reaction. And perhaps, in that moment 12,800 years ago, Earth crossed a line it had been approaching for millennia. Theories diverge, but one thing remains clear. The Younger Dryas shattered the illusion of climatic continuity. It exposed the fault lines beneath our assumptions. It reminded us that the past is not a stable foundation, but a landscape shaped by disruption as much as by pattern. A landscape where rivers can reverse, forests can vanish, and spring can become winter again, all within a single human lifetime. And in the face of that, how do we listen to the silence left behind? The answer perhaps is to turn again to the layers, to the slow, patient archives of the Earth. Ice cores, lake sediments, tree rings, ancient dust, each holds a voice, muffled but not erased, and as the tools of science become more sensitive, that silence becomes decipherable. What was once a blank space in the climate timeline is now a densely annotated mystery, a sudden chill, a 1,000-year interlude, a resumption. We still do not know why it happened, but we know that it did. And sometimes, that is the most important thing to remember. The Younger Dryas is not just a question about the past, it is a mirror held up to the present. In a time when Earth is warming faster than ever before, when ice sheets once again melt and currents show signs of instability, we return to this ancient event not as an academic curiosity, but as a warning. A story that begins again. If Earth once snapped into cold to preserve balance, what might it do in response to the opposite extreme? This is why the debate remains so alive. Scientists from different disciplines, climatologists, geologists, archaeologists, astronomers, each bring their pieces to the puzzle. Some see a freshwater flood, others see fire from the sky. Some see both, layered and intertwined like strands of a braided river. And a few see neither, focusing instead on internal variability, the natural lurching of complex systems. But all agree on one thing. The Younger Dryas was not an ordinary chapter in Earth's history. It was a rupture, a reminder. There is a phrase often used in climate science, non-linearity. It means that small changes can produce outsized effects, that trends do not always continue in straight lines, that stability can give way to chaos with little warning. The Younger Dryas is perhaps the oldest and clearest example of this truth. A world moving steadily into warmth suddenly recoils. Why? We may never know for certain, and maybe that is the lesson. Not all mysteries resolve into answers. Some remain open, quiet invitations to look deeper, to think differently, to listen more closely. Because beneath the soot, the melt, the sediment, and the silence, there is a story being told. Not one of doom, but of complexity. Not one of finality, but of adaptation. A story in which even the Earth itself can pause, reconsider, and begin again. So the seeds of suspicion grow, in laboratories, in mines, in the bones of extinct creatures and the charred soil of ancient fires. We are left not with conclusions, but with questions. And in the space those questions create, something else takes root, an awareness, that the past is never truly gone, that the Earth remembers, and that sometimes the planet itself may choose to change, not because it must, but because it can. Beneath our feet the Earth remembers. It remembers in layers, compressed, silent, undisturbed for millennia. And sometimes it leaves behind a sentence so dark, so abrupt, that it demands to be read aloud. Such is the case with the black mats, thin but unmistakable bands of carbon-rich sediment found across multiple continents. They mark the exact moment when the Younger Dryas began. Not with gradual cooling or scattered signs, but with soot, with char, with something burned and buried. What kind of event leaves a fingerprint in fire? At first, these black mats were curiosities. Found at archaeological sites in North America, especially in regions tied to the Clovis culture, they were long thought to be ancient floodplains or periods of reduced vegetation. But as more sites were uncovered, a pattern began to form. From Arizona to South Carolina, from California to Alberta, researchers uncovered the same dark band, lying like a veil between two worlds. Above the layer, a diminished landscape. Below it, a vibrant record of megafauna, human tools and biological diversity. And in between, the silence of ash. These layers did not appear slowly. They were not the product of sediment washed over centuries. They formed abruptly. The carbon content suggested intense fire. The microstratigraphy pointed to a single event, or at least a tightly clustered moment in time, and always, they appeared in the same place within the archaeological sequence, right at the boundary where Clovis artifacts vanish, where mammoths disappear, where something ends. This was no ordinary soil. At the Murray Spring site in Arizona, one of the most well-preserved Clovis kill sites, the black mat lies like a burial shroud. Beneath it are stone points and butchered bones, evidence of life, of thriving, of the ongoing rhythm of the hunt. Above it, none. The tools are gone, the animals are gone, the silence is complete. What could cause such a clean severance in the archaeological record? Could this mat be a tomb, not of individuals, but of an entire epoch. Other sites reinforced the pattern. At Blackwater Draw in New Mexico, at Topper in South Carolina, at Gainey in Michigan. Again and again, the mat appears, always around the same time, always associated with a sudden shift in climate and culture, and as researchers began to analyse its contents, the mystery only deepened. Embedded within the soot and organic debris were microscopic clues, metallic spherules, high-temperature silica, and traces of platinum far above what should be naturally present. Could these mats be the residue of something atmospheric, something explosive? The Earth doesn't speak in paragraphs, it leaves fragments, and from those fragments we are asked to construct a story. One layer of black sediment, one moment of catastrophic burn across 2 continents. Was it a coincidence, or the mark of something more? What kind of fire leaves behind silence that lasts for 1,000 years? To answer that, we must return to the pattern, because patterns are how memory speaks through geology. The black mats, though thin, are consistent, spanning regions and cultures, appearing in layers that suggest not local phenomena, but something hemispheric, even global. What begins as scattered soot transforms, in the eyes of those who study it, into the possible signature of an extinction. Below the mat, in many sites, the bones of megafauna appear in abundance. Mammoths, mastodons, camels, giant sloths, creatures that had survived the Ice Age, adapted to extremes, and walked beside early humans for thousands of years. Their bones show signs of life interrupted, fractured limbs, flint blades lodged in joints, marrow split open by Clovis hands. These were not dying species, they were thriving, hunted, honoured and used, until they weren't. Because above the mat, they are gone. This sudden disappearance, often termed a megafaunal extinction event, is one of the sharpest in the late Quaternary record. It does not resemble the slow waning of a species on the brink. It resembles a fall, a collapse with no visible recovery. Why would so many large animals vanish within such a narrow window of time? Was it climate, disease, human overkill? Or was it something else? An event that wiped the slate, both ecologically and culturally. The Clovis culture, known for its elegant fluted spear points and its wide distribution across North America, also disappears at this boundary. Their technology, so precise, so widespread, is never seen again in the same form. Archaeological layers rich in Clovis artefacts end abruptly at the black mat. Above it, a different world emerges. Different tools, different strategies, different signs of human presence. Some archaeologists argue this suggests replacement by other cultures, others suggest adaptation. But the break is sharp. It is not the evolution of an idea, it is the erasure of one. Could one event truly be responsible for both the extinction of the megafauna and the disappearance of the Clovis? Could one moment of fire rewrite 2 evolutionary stories at once? It is tempting to look away from the scale of such a possibility, to search instead for gradual causes, for the comfort of change that comes gently. But the black mat is not gentle. Its edges are stark. Its message is direct. Something ended here. And the deeper scientists dug into its composition, the more they found. Not just charcoal and organic decay, but signs of processes requiring intense heat, beyond what wildfires alone could explain. Within the mat, and sometimes just above or below it, lay microscopic structures that did not belong to ordinary combustion. Tiny glassy spherules, metallic beads, particles fused at temperatures that suggest lightning, or something greater. And then came the diamonds, not the kind worn on fingers or buried in vaults, but nanodiamonds, tiny crystalline formations so small they can only be seen with the most sensitive microscopes, yet so meaningful they have changed the trajectory of this entire investigation. These diamonds are created under shock, heat and pressure of extraordinary magnitude. They are signatures of violence. They are the mineral witnesses of an event that forced carbon into a new shape. And in the black mats, they are common. Nanodiamonds are found not in every sedimentary layer, not in typical wildfire ash, not in the slow accumulation of soil across time, but specifically in the horizon where the Younger Dryas begins. They are scattered in the places where mammoths vanish and Clovis tools fall silent. They are embedded in the thin darkness like stars trapped beneath the earth. Where could they have come from? What process occurring across continents could make diamonds out of destruction? The list of possibilities is short. Volcanic eruptions can generate intense heat, but they leave other unmistakable traces: ash layers rich in identifiable minerals, and chemical signatures absent in many black matte sites. Wildfires, even the fiercest, do not create the pressures needed to crystallize carbon. Only a handful of mechanisms remain: lightning strikes, which are too localized, or explosions from above. High-temperature melt glass tells a similar story. These glossy fused droplets speak of sand turned liquid, cooled instantly back into solid form, often marked by aerodynamic shaping, as if molten silica travelled through air before falling to the ground. And in some locations, within or just beneath this layer, researchers have detected enrichments of platinum, another clue that points beyond our planet, for platinum is far more common in cosmic dust than in Earth's crust. Spherules, melt glass, platinum, nanodiamonds. The evidence forms a constellation of heat and motion, a constellation that spells out a disturbing implication that the fire in the black mats may not have been born from forests igniting but from the sky erupting. If fragments of a disintegrating comet entered the atmosphere at high velocity, their explosions would unleash incandescent fury, shockwaves capable of flattening landscapes, heat capable of igniting vast swathes of vegetation, molten droplets raining down like sparks from a celestial forge. Entire continents could burn within hours, smoke could choke the sun, and in the aftermath, when the ash settled, the world might look exactly as it does in the archaeological record: charred, emptied, reset. But why here? Why then? Why, just as humanity discovered its first flourishing footholds in the post-Ice Age world, would the heavens intervene with flame? The black mats offer no explanations. They do not speak of causes or motives. They only testify to endings. They show us where the page turned sharply, where the story paused, where something vast and ancient stopped, so something else could begin. And that is the most unsettling question of all. What if catastrophe was the catalyst? In the quiet, steady pulse of archaeological inquiry, that idea resonates like a drumbeat in the deep, because the more we look into the black mats, the more they seem to speak not only of destruction, but of transformation. Something was removed, yes, but in its absence, something else began. A new human world took shape, built atop the ashes of the old, and the ashes themselves, they remain more than metaphor. Under analysis, the forensic content of the black mat layers grows stranger still. Scattered throughout are tiny spheres, microspherules, formed of metals and minerals rapidly melted and resolidified in mid-air. Their shape, their composition, their distribution, these are not products of natural sedimentation or volcanic ash. They bear instead the hallmarks of extreme pressure, high heat, and aerial dispersal. They speak of an event not rooted in the ground, but born in the sky. These spherules are composed of materials like iron, nickel, and silica. Some alloyed in ways found primarily in meteorites. Others contain forms of carbon that suggest temperatures far beyond anything produced by surface fires. Their presence across multiple sites, often precisely aligned with the boundary of the Younger Dryas onset, strengthens a theory that once stood on the margins of academia, that a cosmic impact or a series of airbursts might be to blame. This idea, controversial and still debated, gained momentum in the early 2000s when teams of scientists began cataloguing the geochemical anomalies at various black mat sites. At Abu Huraira in Syria, at Chobot in Canada, at sites scattered across the American Southwest, researchers found consistent patterns: platinum spikes, iridium traces, melt glass, nanodiamonds. It was as if Earth had passed through a debris field, and the resulting bombardment changed everything. Supporters of the Younger Dryas impact hypothesis argue that such an event would explain not only the abrupt cooling, but the fires, the extinctions, the cultural disruptions, and even the apparent global synchrony of black mat formation. If a comet fragmented in the upper atmosphere, it could have unleashed immense thermal radiation, sparking wildfires across thousands of kilometers. The soot would have darkened the skies. The meltwater pulse, triggered by destabilized ice sheets, would have disrupted the Atlantic currents. The cooling would follow, and in the record, the mat. But critics remain. They point out the rarity of direct impact craters from this time. They argue that spherules can have terrestrial origins, that wildfires could have been more extensive due to climate variability or human activity. The debate continues, not just in journals but in labs, in conference halls, and in the sediment itself. Still, the black mats remain. Silent, ubiquitous, unignorable. They do not take sides. They only say, something burned here, something ended here. And in the dark layer left behind, something was sealed. Not just physically, but symbolically. The end of an age, the rebirth of a planet. It's easy, with the distance of thousands of years, to view this through the lens of science alone, stratigraphy, spherules, sediment. But the black mats speak to something deeper than data. They carry the weight of memory, pressed into the earth, as if the planet itself grieved for what was lost and laid down a blanket of carbon in remembrance. These are not just geological curiosities, they are tombstones. In that thin, dark band lies the story of a world interrupted. The extinction of mammoths and mastodons was not just an ecological shift, it was a rupture in the continuity of life as it had been known for tens of thousands of years. Entire landscapes would have emptied. Predator-prey relationships, finely tuned by time, would have snapped. The Clovis culture, tied intimately to these great animals, may have unravelled in tandem with their disappearance. Imagine a people whose survival was built on a now-vanished world, standing in the smoke and silence, and realising that the old patterns no longer applied. Yet, life went on. In the centuries that followed, new technologies emerged. New human adaptations took shape. In the wake of the Younger Dryas onset, we begin to see shifts in hunting strategies, settlement patterns, and possibly even early agricultural experimentation. Perhaps it was necessity, perhaps it was ingenuity. But in the space cleared by catastrophe, evolution stirred. And so the black mats are not only symbols of loss, they are thresholds. We stand as modern humans on the far side of that threshold, descended from those who endured what must have seemed like the end of the world. Their resilience is our inheritance. Today, the questions raised by these layers still echo in the minds of researchers. Was the Younger Dryas triggered by celestial impact, by meltwater and oceanic shutdown? Was it a cascade of natural feedbacks, or a convergence of cosmic chance and earthly fragility? The answer may lie not in any single theory, but in their intersection, a world so finely balanced that multiple forces could tip it. As we gather more data, from Greenland ice cores to Chilean peat bogs, from South African cave sediments to North American burn layers, the black mats continue to guide us, not as answers, but as signposts. They whisper of impermanence, of cycles, of a world that is always more fragile and more interconnected than we imagine. And perhaps most hauntingly, they remind us that history can hinge on a moment. That across the vast sweep of time, the Earth sometimes changes not gradually but all at once. So we kneel beside the dark horizon, brush away the dust of 12,000 years, and listen to what remains, not in fear, not in certainty, but in quiet reverence. Because in this soot-sealed silence, the Earth wrote something down, something it didn't want us to forget, and we, at last, are learning how to read it. What if Earth, in a single moment of celestial reckoning, did not freeze to save itself, but burned to remember what it had forgotten? This is the proposition, at once thrilling and terrible, that has emerged from the smouldering pages of Earth's deep history. That, as the Ice Age teetered on the edge of conclusion, a new force arrived, not from the oceans or the atmosphere, but from beyond the sky. That the Younger Dryas, that strange cold echo in a warming world, may have begun with fire, raining not from volcanoes but from the disintegrating heart of a comet. It is called the Younger Dryas impact hypothesis. And like all hypotheses forged in the tension between science and imagination, it begins with silence and smoke. Across the northern hemisphere, from the vast plains of North America to the sands of Syria, there lies a curious convergence of clues: darkened sediment layers, microscopic spherules, elevated platinum levels, nanodiamonds fused in extreme heat. Each fragment whispers of something unnatural, something explosive, something airborne. The patterns seem too consistent to ignore and yet too incredible to fully accept. Could a comet, fragmented and dying, have struck the atmosphere in a fiery cascade, igniting continents, collapsing ecosystems and altering climate systems in the blink of a geological eye. The evidence begins not with a crater, but with a pattern. Around 12,800 years ago, temperatures plummeted across the globe in less than a decade. For years, the dominant theory pointed to meltwater pulses disrupting oceanic currents. But then came the forensic trail. Black mats rich in soot and carbon, spherules melted in mid-air, and anomalies of rare elements embedded in the boundary layer between the Pleistocene and the Holocene. These were not remnants of erosion or glacial grinding. They were signatures of combustion, of impact, of thermal violence that demanded an origin high above the Earth. But what kind of impact leaves no crater? What kind of fire consumes but leaves behind no central wound? The answer lies not in collision, but in airburst. Imagine a comet, icy, fragile, ancient, shattered as it enters the atmosphere. The fragments, accelerated to cosmic speed, detonate in mid-air, releasing energy rivaling nuclear weapons but spread across thousands of square kilometers. Shockwaves flatten forests. Radiant heat ignites wildfires from horizon to horizon. Dust and soot are lifted skyward, veiling the sun. The planet shudders not from a blow to its surface, but from the breath of a dying, star-born traveller. Is this what happened in that mysterious dawn of prehistory? If so, it would not have been a single point of destruction, but a storm of light and flame descending without warning upon a world just beginning to thaw. The mammoths would not have seen it coming. Nor would the great flocks, the hunters, the settlements, nestled along rivers still finding their names. It was perhaps not the end of an age, but the rewriting of its ending. What happens to a memory that begins with fire? Perhaps it becomes a story, a myth carried forward not in data but in dreams. While sediment layers hold their secrets in silence, human beings speak their memory aloud. Across continents and cultures, tales have been passed down that seem to echo with uncanny resonance. Stories of destruction from the sky, of flames that fell without warning, of days that turned suddenly to night. Could these myths be the long echoes of a Younger Dryas inferno? Among the Klamath people of the Pacific Northwest, a story is told of a great spirit battle atop Mount Mazama, a volcanic mountain that exploded and became what we now know as Crater Lake. The tale speaks of fire and falling stars, of ash covering the land, of a time when the sky punished the earth. Thousands of miles away, the Ojibwa recount the visit of the long-tailed panther, a celestial being that scorched the forests in a single night. In South America, the Piaroa of the Amazon recall the world's destruction by fire that fell from above, followed by floods and darkness. And these are not isolated poetic devices. From the Aboriginal Dreamtime accounts of burning skies, to ancient Indian texts describing smoking chariots and fire from heaven, the parallels are striking. Native myths in North America, Eurasia, and even sub-Saharan Africa all contain variations of this same motif. The sky opening, the earth burning, the end arriving not from within but from above. Skeptics may say such stories are metaphor, and in many cases perhaps they are. Fire has long symbolized purification, judgment, rebirth. But the convergence of myth with the geochemical evidence of sudden combustion, carbon layers, soot, impact proxies, invites deeper reflection. What if these stories are not just symbolic memory, but living testimony? Oral records stretched thin across millennia, retold around fires, sung through generations, surviving where ink would have faded. And what does it mean when science and story converge? For decades, the Younger Dryas impact hypothesis was dismissed as improbable, even fringe. But recent years have seen a slow shift. New studies, published in respected journals, have added weight to the idea that something immense and fiery did in fact occur at the onset of the Younger Dryas. A 2018 paper in Nature's Scientific Reports detailed high concentrations of platinum at Greenland ice core levels dated precisely to that boundary. Other papers have confirmed meltglass in multiple locations, consistent with airburst events. Still, no definitive smoking gun has emerged, no crater large enough, no intact cometry remains. But if the culprit was fragmented and the explosions aerial, perhaps there never was a single impact site. Perhaps the evidence is, by its nature, scattered, like embers thrown from a collapsing fire, landing far and wide, leaving only a pattern for us to trace backward. And so, the sky itself becomes a suspect. To implicate the heavens in such a planetary upheaval is not an act of whimsy. It is a sober conclusion drawn from the evidence left behind in stone, ice, and soil. Scientists analysing sediment cores from across the northern hemisphere have found more than soot and nanodiamonds. They've uncovered melt glass, materials fused by temperatures exceeding 1,700 degrees Celsius, far hotter than any known wildfires. These glassy remnants contain high levels of iridium and osmium, elements more common in asteroids and comets than on Earth's surface. Even more telling are the peaks of platinum found in geological layers dating precisely to the Younger Dryas onset. Platinum group metals are rare in Earth's crust, but not in certain types of meteorites. These spikes show up from South Carolina to Belgium, from Greenland's icy depths to the black mats of Arizona and California. The uniform timing and global distribution of these anomalies suggest not a local event, but a planetary one. And yet, in the cautious world of peer-reviewed science, the impact hypothesis remains hotly debated. Critics point out that wildfires can also leave soot and charcoal, that platinum can come from volcanic activity, that microspherules might form under other high-heat conditions. The standard explanations, meltwater discharge, thermohaline circulation shifts, still hold sway in many quarters. But each year, the list of anomalies grows, and with it, the quiet reconsideration of what might have truly occurred. Enter the Taurid complex, a sprawling stream of cometary debris that Earth passes through twice a year, in June and November. Some astronomers propose that this may have been the original source of the Younger Dryas event. Thousands of years ago, a much larger progenitor comet may have fragmented in the inner solar system, leaving behind a river of dust, ice and rocks, some several kilometers wide. If Earth intersected a dense clump of this material, the consequences could have been cataclysmic, especially if multiple large fragments exploded in the atmosphere over populated continents. The airburst model solves many mysteries. It explains the lack of craters, the widespread distribution of thermal damage, the unusual melt products. It matches with observed phenomena like the 1908 Tunguska explosion in Siberia, which flattened 80 million trees without leaving a crater, its damage zone eerily similar to what researchers propose occurred 12,000 years ago, but on a far grander scale. And it reframes the entire narrative of the Younger Dryas not as a purely climatic anomaly, but as a cosmic interruption. It's a perspective that humbles. It reminds us that while we often think of history as something shaped by human hands, by culture, invention, and will, it is sometimes rewritten by forces far beyond us. By icy wanderers from the Kuiper Belt, by invisible trails of dust and debris left behind eons ago, by fire in the sky. To many early cultures, such fire may not have been a punishment or a natural disaster. It may have been seen as a message, a celestial omen. The sky, once a symbol of order and constancy, had cracked open. And in that moment, everything changed. Across North America, the archaeological record bears sudden scars. The disappearance of the Clovis culture, the vanishing of large mammals, the abrupt shift in climate and biodiversity, and beneath it all, that dark carbon-rich band of sediment, the fingerprint of fire. But while some stories were lost, others endured. In the myths of the Zuni and Hopi, references linger of a previous world destroyed by fire before the birth of the one we now inhabit. In ancient Mesopotamian texts, the sky god Enlil brings down flames upon the earth, reshaping civilization. In Finnish Kalevala tales, a fiery serpent descends to scorch the forests, its path leaving the land barren. These legends, across time and distance, speak in the same symbolic vocabulary, light from the heavens bringing darkness below. And now, as modern science assembles its instruments, a quiet dialogue begins between the ancient and the new. Satellites map the traces of impact proxies. Supercomputers model atmospheric disruption. Spectrographic analysis confirms the mineral fingerprints of extreme thermal events. The stories once told in whispers around campfires are being examined beneath electron microscopes. One remarkable example comes from Abu Huraira, a site in modern Syria once home to one of the first known farming communities. There, in a layer dated to the Younger Dryas onset, researchers discovered melted glass embedded with mineral grains, evidence of exposure to temperatures surpassing anything achievable through human means at the time. The site shows signs of sudden abandonment. Whatever occurred there was not gradual, it was catastrophic. Likewise, in South America, recent studies have identified similar impact proxies, suggesting the event was not limited to the Northern Hemisphere as once believed. The reach of the phenomenon was planetary, the scale unprecedented, and the implications ripple forward to us. Because the Younger Dryas is more than an academic curiosity. It is a window, a dark, scorched window, into how sensitive Earth's systems are, how finely tuned the balance is between warmth and cold, abundance and scarcity, life and extinction, and how quickly that balance can be upset by something as distant and indifferent as a passing comet. But there is also a strange beauty in this story, to know that we are not isolated, that our world spins through a universe alive with motion, risk and wonder, that above our skies are remnants of ancient things, objects older than civilization, older than bones, older than memory, that have shaped our path in ways we are only beginning to comprehend. We are in the end children of the stars, and sometimes our inheritance comes not as light but as heat, as pressure. A sudden silence after a thunderous flame. The Younger Dryas, whatever its precise cause, remains a moment of rupture, when the earth turned sharply from one path to another, not gradually, but with force. And whether it was the result of icy floods or fiery descent, one truth is constant. It reshaped the destiny of life on Earth. The megafauna, mammoths, mastodons, saber-toothed cats, vanished in waves. The Clovis culture, whose fluted stone points once hunted the great beasts of the plains, dissolved into the archaeological shadows. The warming that had once promised the return of green valleys and fertile rains was replaced by a cold wind, a hostile pause in the blossoming of civilization. Humanity, ever adaptive, withdrew into smaller bands, altered its tools, shifted its myths. But fire is not only an agent of destruction. It clears old growth to make way for the new. It forges stronger metal, reveals hidden shapes, and ignites thought. Perhaps the fire that fell, if it truly fell, was not just an ending, but a signal. A moment that bound sky and earth in shared vulnerability. And in that vulnerability, a new resilience began to take root. Even now, as we look up into the night sky, past the atmosphere that shields us and the magnetosphere that wraps us in safety, we see the faint trails of ancient comets. Their names echo like verses: Encke, Temple Tuttle, Swift Tuttle. Some return predictably, some silently disintegrate, leaving dust we walk through without noticing. But they are out there, fragments of the past still circling, still watching, and perhaps if we listen closely, not just to the stars but to the stories, we may hear the memory of that fire. Not as a warning alone, but as a teacher, for it was through fire that the earth was tested, through fire that new life would emerge, and through fire that we remember just how connected we are to the cosmos that birthed us. The story of the Younger Dryas is not finished. Its layers are still being uncovered, each excavation revealing new patterns, each theory refining the shape of an invisible truth. But one thing is certain: it was a moment of deep consequence, a moment when the planet held its breath beneath a sky full of fire. And from that fire, a new chapter began. If the Earth truly froze to save itself, then something, some force, some imbalance, must have demanded that sacrifice. What then broke the rhythm? What unseen mechanism paused the warmth, turned spring into snow, and silenced the birdsong of a rising interglacial age? To understand the Younger Dryas, we must now go deeper, far beneath the forests and ice, beneath even the surface of the sea, to the pulsing circulatory system of the planet. For at the heart of Earth's climate lies an oceanic engine, vast and slow, ancient and essential. It is called the Atlantic Meridional Overturning Circulation, or AMOC, a name as dense and mechanical as the currents it describes. But beneath that technical skin is something more vital, more poetic. This is not just a current, it is Earth's heartbeat, a conveyor belt of water that travels from the tropics to the poles and back again, rising and falling like breath, like blood. It carries heat across hemispheres, regulating the contrast between frost and fire. Warm water flows north along the surface, pulled by winds and Earth's rotation. When it reaches the cold North Atlantic, it cools, grows heavy and sinks, descending into the abyss to return southward in hidden frozen veins. This great loop is slow, deliberate, constant. Or it was. What happens when a heart stutters? Imagine a glacial lake the size of entire countries, hidden behind walls of melting ice. Imagine its waters, ancient and pressurized, held in fragile equilibrium for centuries. Then imagine a sudden breach, a channel opened not by rivers or rain, but by collapse. Glacial Lake Agassiz, a freshwater titan born from the melting Laurentide ice sheet, once spread across the bones of modern-day Canada and the northern United States. For thousands of years it had quietly expanded, cradled by retreating ice. But at some point, some say around 12,800 years ago, it released its burden. Perhaps it happened over weeks, perhaps it happened in days. But one thing is certain, the lake drained catastrophically, pouring a vast deluge of freshwater into the North Atlantic. And freshwater, unlike its salty sibling, is lighter, less dense. When it floods the ocean, it can sit on the surface like a lens, insulating the warmth below. It can choke the descent of heavy, salt-rich currents that drive the amok, and when that descent stops, the entire engine falters. The thermohaline circulation, thermo for heat, haline for salt, relies on contrast, on difference, on the delicate interplay of warm and cold, saline and fresh. The glacial outburst disrupted this balance like a rogue drumbeat in a symphony. Without the sinking of cold water in the North Atlantic, the flow weakened, and with it the warmth that had once crept northward faltered. Europe, newly green and thawing, was suddenly thrust back into cold. Storm tracks shifted. Ice began to return, not over centuries, but within decades. What does it mean, then, for a planet's heart to be silenced? It means a cascading chain of climate systems, once in balance, begin to tip. The warmth withheld in the North Atlantic doesn't just chill the air above Europe, it rearranges the planet's wind belts, disrupts monsoon cycles in Asia, and brings drought where there should be rain. Climate, after all, is not local. It is global, entangled, systemic. When the amok slows or stops, it is not a ripple, but a wave, and that wave touches every shoreline on Earth. For years, the idea that a freshwater flood could stall the Atlantic's great conveyor belt was theory, a model born in computer simulations and climate labs. But over time, physical evidence began to surface, like ancient signals etched into coral, ice, and sediment. Cores drawn from the ocean floor showed sudden changes in temperature and salinity. Layers of microscopic shells recorded colder surface waters and altered marine productivity, just as would be expected if warm currents failed to reach northern seas. Greenland's ice, a silent witness to thousands of winters, bore chemical signatures of a sudden cooling. The timeline aligned too precisely with the proposed meltwater event to ignore. More recently, attention returned to the source, Lake Agassiz. Once reconstructed through glacial geology and now modelled with increasing precision, the lake's catastrophic drainage appears more and more plausible. Shorelines in distant parts of the globe, like the rise in sea levels detected in Caribbean island cores, may well reflect the pulse of Agassiz's final breath. As much as 100,000 cubic kilometres of freshwater may have been released, enough to briefly raise global sea levels by over half a metre. For ocean circulation, it was not just a ripple, it was a chokehold. But perhaps the most revealing aspect of the Younger Dryas cooling is not how it began, but how it sustained. The amok once weakened did not simply snap back. The circulation remained disrupted for over 1,000 years. What was once a transient flood became a semi-permanent rearrangement, and this too speaks to the vulnerability of our climate machine, because Earth's systems are not as durable as they appear. They can be surprisingly sensitive to small changes, especially when those changes arrive suddenly. Climate feedback loops, interacting mechanisms that either amplify or dampen a trend, can trap the planet in new equilibria. Cooling can preserve ice. Preserved ice reflects more sunlight, which causes further cooling. Oceans can store or release heat depending on circulation patterns. Vegetation can expand or shrink, altering the land's reflectivity and carbon exchange. In the Younger Dryas, the feedbacks aligned in such a way that a 1,000-year winter settled over vast regions of the Earth, even as orbital patterns still favoured warming. The planet, in a sense, resisted its own springtime, and so we find ourselves staring at a sobering truth. When the heart of the ocean skips a beat, the entire body remembers. The Younger Dryas, then, becomes more than a climatic anomaly. It becomes a case study in vulnerability, a reminder that even in the grandeur of Earth's long rhythms, sudden shifts can occur. The ocean, often imagined as slow and immutable, reveals itself as dynamic and reactive, and the currents, invisible to the eye but mighty in their reach, become central actors in the drama of Earth's climate. To fully understand the consequences, we must return to the great conveyor, the AMOC, and imagine it not as a singular flow, but as a symphony of density, depth, and delay. The circulation depends not just on the movement of water, but on its properties. Salt and temperature, yes, but also timing. When fresh water enters too quickly, it can overwhelm even the immense inertia of the deep sea. And that's what makes the Lake Agassiz event so extraordinary, its suddenness. It is hard to fathom the scale of a meltwater pulse when viewed from our small human lifespans. But imagine a wall of fresh water pouring into the ocean, volume upon volume, hour after hour, cool, clear, and persistent. This wasn't just a lake emptying, it was a climate system reconfiguring itself in real time. Satellite imagery doesn't exist for the event, of course, but if it did, we might have seen swirls of blue-grey clouding the Atlantic, plumes of sediment-rich outflow threading their way through ancient fjords and inlets, carrying with them the memory of vanished glaciers. And it's here that the idea of a disrupted heart becomes more than metaphor. The Emosi is the engine that redistributes thermal energy, yes, but it also governs the delivery of nutrients and oxygen across the deep ocean. Its weakening would have affected marine life, fisheries, and even atmospheric carbon levels. In some regions, primary productivity may have declined. In others, cold-loving species would have reclaimed space. The ocean's breath, its inhalations and exhalations of carbon, would have been altered, perhaps affecting the global climate in ways still not fully understood. More eerily still, the stalled AMOC likely shifted storm tracks, redirecting the path of the jet stream. In Europe, this brought not just cold, but aridity, a drying of lands that had only just begun to flower. In the tropics, monsoons may have weakened, failing to deliver vital rains. In the American Southwest, signs of abrupt drought have been found, seemingly echoing the patterns of global atmospheric disruption, all of it rippling outward from the collapse of a single glacial reservoir. It raises a quiet but pressing question. How stable is the balance we live in today? Because while the Younger Dryas was an ancient event, the mechanisms that caused it, the ocean conveyor, the sensitivity to fresh water, the feedback loops, still operate now, silently, beneath the surface of our modern climate. They are still moving, still circulating, still listening to the balance between salt and temperature, weight and flow. And as we melt glaciers again, this time not from retreating ice sheets but from industrial heat, the old vulnerabilities return, not as echoes, but as warnings. But let's stay in the deep past for just a moment longer, because there is a strange, sobering elegance to how it all unfolded. The glacial lake, the collapsed ice dam, the sudden release, these were not acts of human will or ambition. They were quiet inevitabilities of physics, a chain of pressure and volume, of weight and flow. The lake had to drain eventually, the ocean had to respond, and Earth, being the subtle system it is, settled into a new state not because it wanted to, but because it had to. The Younger Dryas, in this way, becomes an example of climate's tipping points. These are thresholds, often invisible, where systems shift not gradually, but suddenly, flipping into new configurations from which return is difficult or slow. The AMOC may have passed such a threshold during the meltwater pulse, and once crossed, the balance held not for years, but for over a millennium. And yet, when it did end, when the AMOC eventually resumed and warmth returned, it did so in a matter of decades. Greenland's temperatures rose sharply once again. Climate systems reoriented, forests advanced, glaciers retreated. It was in its own way another heartbeat, the rhythm resuming. But the time between that long winter, that 1,000-year pause, reminds us that climate does not always change smoothly. It changes in jolts, in lurches, in great and sudden silences. It's worth reflecting on what this meant for the people of that time. The human cost of such climate volatility was immense. The Younger Dryas would have upended ecosystems across entire continents. Herds of megafauna, already stressed by a changing world, collapsed further. Food sources dwindled. Landscapes shifted from fertile to frozen. And while the Ice Age had been long and brutal, it had at least been stable. This new cold was different. It came when hope had returned, when the world had begun to thaw. And perhaps that is what made it so traumatic. Our ancestors had started to settle, to sow, to explore new ways of living. The Holocene, that temperate age of agriculture and architecture, had seemed just around the corner, but then came snow, then came drought, then came loss, and all of it, because the great heart of the ocean had skipped a beat. But perhaps that is the deeper truth of the Younger Dryas. Not that it was an apocalypse, but that it was a lesson in interconnection. A lake drained on one continent, currents shifted across an ocean, storms changed halfway across the world, life retreated, and eventually life returned. The earth breathed through it all, though raggedly, as though startled by its own capacity for transformation. We often imagine climate as background, static, dependable, the silent stage upon which history unfolds. But in moments like the Younger Dryas, climate is history. It doesn't merely support human life. It shapes it, redirects it. Sometimes it silences it. And yet, it also teaches. The ocean's vulnerability reveals its sensitivity, its attunement to the delicate balances of water, temperature, and time. The amok, like any vital organ, performs in silence until something interrupts it. And then its absence speaks volumes. The 1,000-year cold that followed the flood of Lake Agassiz may have spared the planet from overheating. But it did so at a price, a kind of planetary hibernation that left scars in ice, in bones, in myth. Modern science continues to search these scars, reading the layers of sediment like sentences, analysing isotopes as punctuation marks in Earth's diary. The more we learn, the more the Younger Dryas becomes not just a paleoclimatic puzzle, but a parable about balance, about fragility, about the rhythms that govern life on Earth. Because now, as ice sheets once again diminish and meltwater pours once more into the North Atlantic, the ghost of that ancient event stirs again. The amok is measured today by an array of satellites, buoys, and deep-sea sensors, and some signals suggest it is slowing, not dramatically, but perceptibly. Enough to raise eyebrows in quiet conference rooms, enough to whisper that history, if ignored, may yet repeat itself. But this chapter is not meant to be ominous, it is meant to be clarifying. The Younger Dryas was not a punishment. It was a response, a moment when the Earth, overwhelmed by imbalance, chose a radical recalibration. And from that choice, a new age would eventually bloom. The Holocene would come, forests would return. Humans would plant and settle and build. The memory of the cold would pass into story, into cautionary tale, and deep beneath the surface the great currents would stir again, slowly, steadily, as if waking from a long and necessary dream. They left behind no farewell, only blades of flint and broken bones, scattered across the North American landscape like punctuation at the end of a vanished sentence. The Clovis people, once masters of the great mammoth hunt, disappeared from the archaeological record just as Earth entered the Younger Dryas. And in that disappearance lies a question that hums beneath this entire story. If the Earth froze to save itself, whom did it abandon to the cold? Clovis was never a single village, never a kingdom, never a name they gave themselves. It was a style, a signal, a fingerprint pressed into the stone. Sleek, fluted spear points carved with precision from chert and obsidian spread like wildfire across the continent nearly 13,000 years ago. They tell of a people who moved with the land, chasing the great beasts of the Pleistocene, the mastodon, the gomphothere, the giant ground sloth. With each migration, the tools followed, leaving trails of evidence from Montana to Mexico, from Nova Scotia to New Mexico. But the tools are not just remnants of survival, they are signatures of thought. To craft a Clovis point was to understand fracture, pressure, intention. To hold one is to hold an echo of cognition, of foresight, of communication across generations. Who taught the young hands to strike stone so cleanly? Who whispered through the rhythm of percussion, guiding each chip and flake? Their lifestyle was a dance of movement and adaptation. Nomadic, yet bound by knowledge. Rootless, yet rooted in the cycles of the earth. They moved with the seasons, they tracked the herds, they read the rivers. Their campsites speak of fires built beside ice-fed streams, of bones cracked for marrow, of children who played while the snow fell quiet upon the grass. This was not a primitive people, it was a people attuned, and yet, at the very height of their spread, the Clovis vanish, not gradually, not in a slow diffusion or merger with neighbouring cultures, but in a silence so sharp it cuts through the sediment. Within what may have been a single generation, the Clovis toolkit disappears from the archaeological record. Their spear points cease to be made, their campsites grow cold, their trails dissolve into the dust. What happens to a people when the world around them changes faster than memory can adapt? Some say the great beasts vanished, and the Clovis with them. A culture built on mammoth hunting could not survive the extinction of its prey. Others suggest they were not extinguished, but transformed, adapting to new realities, new strategies, leaving behind their signature not because they died, but because they evolved. But then, why the sudden silence? Why does the earth not whisper their name again for centuries? And in the darkest corners of the hypothesis, there is another possibility. That the Clovis were not merely victims of biology, or of culture, but of catastrophe. Could a fire from the sky have erased not only forests and herds, but memory itself? What if their disappearance was not a fading, but an erasure? The very notion that the Clovis culture was wiped clean in a moment, obliterated, not assimilated, leads us to look more closely at the ground they once walked. In layer after layer of ancient soil, archaeologists began to notice a troubling pattern: black mats. These dark sediment layers, rich in carbon and often capped by a sudden absence of Clovis artifacts, seem to mark a geological dividing line, a moment when something irrevocable occurred. Beneath the mats lie Clovis tools, butchered mammoth bones, fire rings, and the residues of daily life. Above them, silence. Other cultures, yes, but different ones, different tools, different lifestyles. It is as if a cultural thread had been cut clean, leaving a void between what came before and what followed after. Some researchers believe the Clovis simply adapted, that they took on new identities in response to a changing world. But others see something more abrupt, more violent. Evidence has emerged, subtle, granular, forensic, of a potential cosmic event. Microscopic spherules, consistent with high-temperature impacts, elevated levels of platinum, even nanodiamonds formed under extraordinary heat and pressure, all dating to the same moment in time, all buried within or near the black mats. Could it be that the sky opened and fire rained down upon a continent? This theory, known as the Younger Dryas impact hypothesis, remains controversial. It suggests that fragments of a disintegrating comet or asteroid entered Earth's atmosphere and detonated above North America with enough force to ignite wildfires across thousands of miles. Such an airburst would not leave a crater, but it would leave destruction, a flashpoint, a moment of annihilation. If true, the implications are profound. The Clovis people may not have faded into history but been interrupted by a cataclysm that struck not just the land but the memory of the land. Forests would have burned, animals would have fled or died en masse, food sources would have collapsed, and in the chaos, cultures tethered to fragile ecosystems would have unravelled. Yet even if the impact hypothesis is never fully proven, the archaeological silence remains. Something happened, something sharp, sudden and synchronous. It was not just the mammoths that vanished, it was the hands that hunted them, the songs sung around fire, the passed down knowledge of where to find stone, how to strike it, how to live with the rhythm of earth. And so we are left with absence, not just in the ground, but in the story itself. In many ways, the Clovis people stand as symbols of a broader mystery. How civilizations, however small, however mobile, can vanish when the world changes too quickly. And how the traces they leave behind, whether in flint or carbon, are fragile threads in a tapestry that time is always trying to unweave. The ghosts of Clovis remain, not in name but in silence, And silence for archaeologists is both a puzzle and a presence. It asks more questions than it answers. Why, for example, does the Clovis signature disappear almost universally across the continent within what appears to be a single generation? There is no clear evidence of war, no sign of slow cultural drift, only the vanishing of a technology, a pattern of life, and a way of seeing the world, erased as cleanly as a torch blown out in the wind. To find answers, researchers turn to the tools themselves. Clovis points are remarkable in their craftsmanship, but also in their uniformity. Their fluted channels and sleek symmetry appear again and again across great distances, suggesting not just cultural cohesion, but shared knowledge over vast lands. It wasn't merely a local innovation, it was a unifying signature of a people spread across a continent, and then nothing. The post-Clovis period brings new tools, new forms, fishtail points, stemmed blades, regional adaptations, but the unity is gone. In its place is fragmentation, localism, diversity. This suggests not a seamless evolution, but a fracture, a rupture in the cultural lineage. Something broke the chain of inheritance. Was it environmental trauma, a biological bottleneck, or a psychological scar so deep that people deliberately abandoned the symbols of a past that could no longer protect them? In the decades after the Younger Dryas onset, much of North America was transformed. What had once been grasslands teeming with megafauna became tundra or forest. The prey animals central to Clovis survival, mastodons, mammoths, giant bison, either vanished or were pushed to the brink. The rhythms of the land shifted. So too would the rhythms of life, and in such upheaval, survival demands innovation. Cultures fragment, knowledge is hoarded, hidden, lost. New ways emerge, but only after the silence has passed. Some believe the survivors of the Clovis era simply became someone else, adapting, evolving, living in new forms that archaeology hasn't yet fully understood. There is compelling evidence for continuity in some regions. A child's footprint in a stream bed here. A hearth still used, but for different foods, in a different time. These are not signs of total collapse, but of transformation through trauma. Others look to myth. Native oral traditions from across the Americas speak of fire from the sky, of floods and famine, of a long winter that followed a day of heat and smoke. These are not data points, but they are stories. And stories too are records, woven not in stone but in voice and memory. Perhaps the Clovis did not disappear at all. Perhaps they endured in tale and bloodline, even as their tools fell silent. But archaeology deals in fragments, and sometimes the fragments whisper of things too large to name directly. The Clovis people were not the first to vanish, nor would they be the last. But their silence marks a boundary between the world that was and the world that followed. And in that boundary, researchers are beginning to see the outlines of something deeper, a moment not merely of extinction or disappearance, but of transition, of rupture, like the snapping of a drum skin or the sudden silence after a bird's call. The Clovis people were not simply erased, they were the last breath of a continent before it exhaled into something new. To explore this transformation, we must follow the geological clues that lie buried alongside the cultural ones. At sites like Murray Springs in Arizona or Topper in South Carolina, archaeologists have uncovered strange assemblages, kill sites that show signs of sudden burning, soil horizons rich in magnetic spherules, and carbon layers dense with soot and ash. These are not ordinary remnants of fire, they suggest combustion on a continental scale. What kind of event could cause such sudden, widespread incineration? The comet hypothesis returns here, not as a fringe idea, but as a growing focus of inquiry. According to this theory, Earth passed through a debris field from a disintegrating comet roughly 12,800 years ago. Multiple airbursts, massive explosions in the upper atmosphere, would have created a cascade of firestorms, igniting forests and grasslands, destabilizing ecosystems, and plunging the climate into chaos. A flashpoint that left little behind except soot, silence, and loss. In such a scenario, the Clovis people would not have seen it coming. They may have awoken one morning to a sky split by fire, heard scattering and panic, and the scent of smoke drifting over once familiar plains. Within days, perhaps even hours, their world could have transformed into something unrecognizable. And in the wake of that upheaval, they would have had to choose adapt, or vanish. Some scholars argue that this was not a universal extinction, but a demographic thinning. That many Clovis groups were isolated, their mobility disrupted by the ecological collapse. Those who survived would have lost access to keystone quarries, to known hunting grounds, to rivers that once flowed steadily. In this new geography of uncertainty, communities would splinter, and the traditions that once bound them, like the making of Clovis points, might fall away out of necessity. But there is also a human cost that archaeology can only hint at. What does it mean to lose your elders, your stories, your maps of meaning? To walk through a forest you once knew, now burned to charcoal? To hear no more mammoth calls in the valleys nor songs from your kin? These are the intangible losses, the cultural extinctions that accompany the biological. The ghosts of Clovis are not just the people we can no longer find, but the ways of being we can no longer imagine. And yet, their absence taught us to look differently, to listen for faint echoes in the soil, to search for memory in the form of stone, and to wonder how much can be lost before we forget that it was ever there. Because while the Clovis culture has vanished from our sight, it has not entirely vanished from our story. The very fact that we can speak their name, hold their tools in our hands and follow the trail of their passing is evidence that they left a mark, not just in the sediment, but in the shape of questions we still carry. Where did they go? Why did they disappear? And what does their silence teach us about our own fragility? The Younger Dryas was not merely a cold spell. It was a planetary pause, a recalibration of Earth's systems in the face of imbalance. In that icy interlude, species vanished, glaciers surged, forests died, and the Clovis way of life came to a halt. It is tempting to place the blame on external forces, comets, floods, fires, but perhaps the greater truth lies in how those forces revealed the delicate balance of a world in transition, and how quickly a complex, mobile, adaptive culture can vanish when the balance breaks. In a way, the Clovis disappearance is not just a historical curiosity, it is a mirror. It reminds us that no culture, however widespread or advanced for its time, is immune to environmental change. That no Sierra, no matter how successful, is promised a future. And it also reminds us that extinction does not always come with a roar. Sometimes it arrives as a whisper, a slow unravelling, a quiet fading into myth. What we call collapse may in fact be metamorphosis, a shedding of forms, a reimagining of survival. In the centuries after the Younger Dryas began, new cultures emerged. People adapted, moved, innovated. The seeds of a later civilizations were planted in the soil left behind by the Clovis. Though the tools changed, the hands that shaped them still remembered what it meant to live with the land, to read the stars, to listen to the turning of the seasons. That legacy did not end, it transformed. And perhaps, in that transformation, the ghosts of Clovis found their way forward. Today, when we find a fluted point buried beneath centuries of soil, we're not just uncovering a tool, we're reopening a story, one of resilience, of fragility, of mystery. We're listening once again to the deep rhythms of prehistory, and in that listening we draw closer to the quiet wisdom of those who came before. The Clovis may be gone, but their silence still speaks, and in the long corridors of time, where memory softens into earth and story, they walk beside us still, reminding us that even the most ancient paths were once walked with purpose, wonder, and firelight. In the cold stillness that followed, entire species vanished. The mammoth, the giant ground sloth, the saber-toothed cat. What do their disappearances reveal about Earth's tipping points? What happens to a world when its most ancient voices go silent? Imagine it. Herds of towering mammoths moving across vast, icy plains, their footfalls muffled by snow and time, the distant roar of a saber-toothed cat echoing through boreal forests, the slow, lumbering breath of a ground sloth heavier than a modern truck, brushing against trees long since lost to history. These were not ghosts, they were living, breathing players in Earth's last great icebound theatre. And then, in a geological heartbeat, they were gone. They did not vanish quietly, their absence was deafening. Across continents, bones littered the land like punctuation marks at the end of a story no one finished reading. From Alaska to Patagonia, from Siberia to the American Midwest, skeletal remains of the Pleistocene's giants lie entombed in sediment, silent witnesses to a catastrophe too vast, too complex, and perhaps too intimate to fully name. What event, what chain of forces could silence so many lives so quickly? The term megafauna itself feels clinical, almost sterile. Yet what it describes is a lost menagerie of wonders. Mammoths, with tusks curling like ancient calligraphy. Giant beavers the size of modern black bears. Short-faced bears towering over humans, fast enough to outrun a horse. Camels, horses and lions, not in Africa, but in North America. Armoured glyptodonts, heavy as small cars. These were creatures of deep time, adapted to a world of ice and fire, cold and resilience. They had survived countless glacial pulses and retreats. But the Younger Dryas was different. Was it the cold? The return of frigid conditions might seem a likely culprit, and yet these species had endured colder ages before. Their extinction does not align with the cold alone, it aligns with a threshold, a convergence, a crossing of invisible lines in Earth's balance, and perhaps that is the true lesson buried in permafrost. Extinction is not simply an act of subtraction, but of rupture, a disintegration of interwoven threads. What happens when the climate turns, not slowly, but all at once? In less than a human lifetime, the Earth's warmth reversed. Temperatures plummeted by as much as 10 degrees Celsius in some regions. Grasslands froze. Rivers turned to stone. Migration routes became death traps. And food, the very essence of survival, grew scarce. For grazers, the changing plant communities spelled starvation. For predators, the disappearance of prey meant a tightening noose. Ecological collapse does not move in straight lines. It cascades, topples, entangles. But even that is not the whole story, because alongside this cold came something else, something darker. Fire in the skies, perhaps. A sudden pulse of fresh water disrupting the ocean's lifeblood, or a perfect storm of climate, pressure and human arrival. Was it one factor, or many, that pushed the world past its tipping point? And more haunting still, what does it mean that such giants could fall so fast when they had endured for tens of thousands of years? How fragile is the boundary between dominion and disappearance? How close are we always to the edge of silence? That question lingers like frost upon the air, for silence is never merely the absence of sound, it is the absence of life. In the centuries following the Younger Dryas onset, ecosystems unravelled with uncanny speed. The Great Mammoth Steppes, once a tapestry of grass and giants stretching from Europe to Alaska, withered beneath the weight of snow and shifting skies. The ice returned not as an enemy, but as an unfeeling tide, reclaiming the lands that warmth had briefly set free. And as it did, the world's balance faltered. The end of the megafauna was not a singular moment, but a slow crescendo of disappearance. The mammoths lingered longest in the north, their echoes surviving on isolated islands like Wrangel and St. Paul, where they dwindled into miniature ghosts of their former majesty. Elsewhere, the saber-toothed cat, Smilodon, vanished as prey thinned and forests replaced plains. The giant ground sloth, that ancient gardener of the Americas, fell silent, leaving behind claw marks frozen in caves that no longer held its warmth. The dire wolf, the American lion, the short-faced bear, all disappeared within the same tragic horizon. Yet extinction is not chaos. It has its patterns, its choreography. In bone beds scattered across continents, we see the frozen record of ecological collapse, layers of sudden death, abrupt endings and sharp transitions in species diversity. It is here, among the fossils, that the scale of the catastrophe becomes clear. The extinction event was not isolated by geography or confined to one ecosystem. It was planetary. It swept across every biome like a slow, invisible wave, sometimes silent, sometimes violent. But why? Why did the web tear where it did? Some scientists point to the changing vegetation, the replacement of nutrient-rich grasses with cold-tolerant shrubs and mosses. Herbivores, deprived of their ancient diet, weakened and starved. Predators, in turn, fell victim to hunger's echo. Others suggest a more sudden blow, a burst of cosmic fire that scorched the skies and rained debris across continents. In the blackened soil of North America, Tiny spherules of platinum and nanodiamond glint like the remnants of a celestial crime scene. They whisper of impact, of heat, of airbursts so immense that herds could have perished in an instant. And through it all, the human presence grows undeniable. Clovis hunters, masters of fluted spear points and organised hunts, arrived amid this unravelling. To them, the megafauna were both sustenance and symbol, an inheritance from the Ice Age itself. But inheritance can become debt. Overhunting, stress from a shifting climate, and ecological fragility may have conspired in fatal synergy. Humans did not create the cold, but they adapted faster than the creatures they pursued. They stepped into the vacuum that extinction left behind. This is how ecosystems collapse, not through one act of violence, but through a series of small, accumulating imbalances. When the mammoths fell, the grasslands changed. When the grasslands changed, the soil shifted. When the soil shifted, entire weather patterns followed. Life and climate are partners in a fragile dance. When one stumbles, the other falls. And so the great silence deepened. Across the northern plains, the winds swept over bones and dust where herds once thundered. Forest crept into the spaces where tundra had lain bare. The earth was rewriting its story line by line, erasing characters that had walked its pages for millennia. Was this the end of an age, or the beginning of another? Could the world have chosen differently? Or was the fall of the giants a necessary sacrifice in Earth's long cycle of transformation? That is the unbearable weight of extinction. It feels both inevitable and wrong. In the silence left behind, we search for meaning, for motive, for some thread that binds together the final cries of species that had endured since before we had a word for history. And so we dig. We dig through layers of time, through strata and stone, sifting the dust of vanished giants for the secrets they forgot to leave behind. And what we find, buried deep in riverbanks, caves and tar pits, is not just death, but testimony. Bone beds scattered across the continents are not mere cemeteries, they are archives. They are records of planetary trauma frozen in the moment of collapse. In places like Rancho La Brea in California, the tar has preserved entire Ice Age communities. Mammoths, saber-toothed cats, dire wolves, even beetles and leaves, locked together in sticky death. Elsewhere, in the alluvial fans of the Yukon, in the muck of Siberian permafrost, mammoths lie whole, flesh and fur intact, as if they had merely lain down to rest. In the plains of Alberta, extinction horizons mark abrupt transitions, where below lie the relics of a thriving world, and above, silence. What caused these sharp boundaries? The precision of the change is chilling. In layer after layer of sediment we see a line, thin, dark, sometimes glittering with particles not of this earth, beneath which a world existed and above which it did not. Carbon-rich black mats found at archaeological sites across North America and the Middle East coincide with the onset of the Younger Dryas. These mats, filled with soot, organic decay, and the detritus of charred ecosystems, are the forensic fingerprints of a world in crisis, and within them, clues, microspherules, glass-like beads formed in intense heat, platinum, rare in Earth's crust but abundant in meteoric material, nanodiamonds, minute, impossible formations that require tremendous pressure to create. All of these are scattered like breadcrumbs through the dark layers of the Earth. If the planet were a witness, then these are its bruises, its burn marks, its confession. But even as the evidence mounts, so too does the uncertainty. Could a single comet, fragmenting in the sky, have devastated entire ecosystems? Could firestorms alone cause a collapse so vast? Or was this merely the spark that ignited a dry, waiting forest of ecological fragility, climate, vegetation, overhunting, all fusing into a cascade from which there was no return? The truth, like the bones, is layered. Some scholars argue passionately against impact hypotheses, pointing instead to the deep, slow workings of climate and biosphere. Others see in the black mats and extinction horizons the unmistakable pattern of sudden violence. But the Earth does not debate. It remembers, and its memory is long and cold and strangely quiet. What is the sound of an extinction? Not the roar of the dying, but the stillness that follows, a silence so complete that it transforms the air itself. For once, these lands rang with the footsteps of mastodons, the rustling of giant sloths through ancient canopies, the rumbling growl of predators that no longer prowl, and now only echoes. How do we measure the weight of what is no longer here? Is it in bones, in sediment, or in the haunted spaces those creatures once filled? Perhaps it is in all of them at once, the physical remnants, the ghosted landscapes, and the stories etched into our genetic memory. Because even if we did not know the mammoth, we remember it. In dreams, in myth, in the primal imagination of a species that came of age surrounded by giants. We walked beside them once, and perhaps we still walk in the shadow of their absence. The loss of megafauna was not merely the death of animals, it was the death of relationships. Mammoths shaped their environment by trampling paths, uprooting trees, spreading seeds. Their presence sculpted entire ecosystems. When they vanished, the tundra changed. Grasses yielded to shrubs, forests crept across plains. Fire regimes shifted, and biodiversity realigned around a new and smaller reality. The fall of the giants was a wound that bled outward, not just vertically through time, but horizontally across every system that had depended on their mass, their movement, their metabolism. This is what ecological trauma looks like. It's not a clean break, it's a disintegration, a loss of complexity. When an apex herbivore disappears, the cascade affects more than just predators. Insect populations shift, pollination patterns break, nutrient cycles reroute. When entire guilds, giant grazers, top predators are removed, the ecosystem doesn't simply adjust. It stutters. It collapses into a simpler form, like a symphony stripped of all but a single note. The planet survived the Younger Dryas, but it did not survive unchanged. And yet, amid the ruin, something else endured. Smaller creatures filled the vacuum. Humans adapted. Agriculture, perhaps born in desperation, emerged in the Fertile Crescent during this time of scarcity. Our ancestors did what the megafauna could not. They turned catastrophe into invention, but the cost was incalculable. The richness of the Pleistocene biosphere, the teeming abundance that once covered the world like a second skin, was reduced, narrowed, and in many places lost forever. We inherited a quieter world, but not a silent one. Even now, the Earth bears scars of that ancient trauma. The permafrost still holds the carbon of vanished forests. The soil still remembers the absence of trampling feet. The DNA of extinct species lingers in frozen marrow and dusty sediments, and deep within our cultural memory, symbols of the lost beasts endure, painted on cave walls, carved into stone, woven into story. Why do we still speak of the mammoth with reverence? Why does the saber-toothed cat stir such visceral awe? Why do we feel, even now, that something vital went missing? Perhaps because extinction is not only an ecological event, it is an existential one. It forces us to confront the limits of life, of adaptation, of continuity. It shows us that no lineage is eternal, no dominion secure. And it whispers a question we cannot ignore. If they could fall, could we? In the silence of the vanished, we hear a warning, not shouted but whispered, not aimed but offered, a plea from the bones beneath our feet, from the dark layers in our soil, from the winds that sweep across empty steppes. Remember us. Learn from us. Will we? That is the final burden of silence, that it demands an answer, not just in science, but in soul. Because if we are the inheritors of a world that once held giants, we are also the stewards of the fragile balance they once walked. Their extinction was not only a past event, it is a mirror, cracked and half buried, in which we might glimpse our own reflection. The Younger Dryas was a chapter of reckoning, but the book remains open. From extinction horizons and fossil beds, from soot-streaked strata and ancient soil, a pattern emerges, not just of death, but of thresholds, points at which systems falter, stumble, and fall. The mammoth did not die because it was weak. It died because the world it depended on changed faster than it could follow. And what is climate change, if not the turning of that same wheel? What is the warming of oceans, the acidification of rain, the retreat of ice, if not echoes of that long-ago winter? The Earth remembers. It records trauma in layers, in isotopes, in charred seeds and scorched horizons. It writes its diary not in ink but in extinction. The megafauna were chapters, bold, immense, breathing, and their disappearance was punctuation, a pause, a page turned, but not perhaps an ending. For even as we unearth their bones, we unearth our own origins. We too are creatures shaped by trauma, by upheaval, by cold and fire. The story of the Younger Dryas is not just one of loss, it is one of transformation. In the ashes of ecosystems, humans learned to bend grain to their will, to domesticate animals, to build permanence from uncertainty. We became architects of survival. But at what cost? In that transition, from a wild world of giants to a cultivated world of scarcity, we traded the symphony of ecological richness for the rhythm of control. We survived, yes, we adapted. But we did so by stepping into a silence that we helped create. And that silence lingers still, in vanishing forests, in dwindling species, in the strange quiet that follows the crash of biodiversity. And yet, the bones are still speaking. Every mammoth tusk, every sloth claw, every soot-blackened layer of soil, they call to us across time, not just as relics, but as guides. Their message is not despair, but awareness, a kind of sacred memory encoded in sediment, urging us to listen, to learn, to act, to remember that life is not guaranteed, and that ecosystems, once broken, rarely heal as they once were. What then do we owe to the silence? Perhaps reverence, perhaps vigilance, perhaps the courage to see in the fall of the megafauna not just a tragedy, but a threshold, a turning point that warns us not to repeat the cycle. If extinction is the final silence, then our response must be a vow to keep listening, to the earth, to its thresholds, to the fragile hum of life still left. Because when giants fall, it is not only their voices we lose, it is the music of a world that once sang in harmony with them. And in that fading music we must decide, will we become its echo, or its renewal? In the silence of the vanished we hear a warning, not shouted but whispered, a plea from the bones beneath our feet, from the dark layers in our soil, from the winds that sweep across empty steppes. Remember us, learn from us. But what if someone did? What if, long before the wheel or the plough, long before the first kings built walls or wrote their names in stone, a people looked up at the same sky and carved their memory into the bedrock of the earth, not to preserve power, but to preserve warning. High on a hill in southeastern Anatolia, a place once overlooked as a mere bump in the landscape now casts shadows across our understanding of early civilization. Göbekli Tepe, Potbelly Hill, rises not with grandeur but with mystery, and beneath its rounded silhouette lies a secret far older than cities, kings, or written word. Dated to at least 11,600 years ago, Göbekli Tepe defies our linear assumptions about progress. It is not a village, it is not a farm, it is not, in the way we think of it, a home. It is a temple, or something like one, built not by sedentary farmers but by hunter-gatherers who had not yet domesticated wheat or penned livestock. Massive T-shaped pillars, some weighing over 16 tons, were carved from local limestone and arranged in concentric circles, each stone etched with animals, symbols and signs. There are no burials here, no hearths, no middens of daily life, only memory, cut into stone. Why would a people without agriculture build a monument of such ambition? What compelled them to quarry, transport and shape monoliths with no beast of burden, no wheels, no metallurgy? Was it faith? Was it fear? Or was it the need to remember something so vast, so devastating, that only stone could carry its weight? Some have called Göbekli Tepe the world's first cathedral, but it is more than that. It is a riddle. And at its heart is timing, because the temple rises not long after the earth itself was scarred. The Younger Dryas, a 1,000-year-long winter that followed a sudden reversal of warming, had just ended. The planet had turned from fire to ice and back again with terrifying speed. The last mammoths had perished. The great fauna had fallen, human bands scattered, some vanished, some endured. And in the aftermath, amid the trauma of survival, someone began to carve circles in stone. Could Göbekli Tepe be the scar tissue of memory? Could it be an act of ritualized remembrance, a sacred layer of response to a planetary wound? And what do the carvings tell us? Foxes, snakes, boars, vultures, headless figures, not decorative but deliberate. Not mere representations of fauna but symbols, perhaps constellations, perhaps omens, perhaps fragments of a story whose grammar we no longer speak. What does it mean that these stones predate the pyramid by 7,000 years, that they whisper of a cosmology rooted not in conquest but in survival? What does a monument to memory look like when the world has nearly ended? Perhaps it looks like a ring of stone, unroofed, open to the sky, built not to shelter but to speak, and not to the living alone but to the cosmos itself. For Göbekli Tepe is not only old, it is oriented. The positioning of its enclosures, the angles of its pillars, the carvings that spiral around them, none of it is accidental. Researchers have long puzzled over the site's purpose, but one thread returns again and again: the sky. That vast, unchanging canvas above, a place of patterns, portents, and permanence when the earth below trembled with uncertainty. What if Göbekli Tepe was a star map, or more precisely a celestial record, an attempt to remember what happened in the heavens when the earth changed forever? Some scholars have proposed that the animal motifs carved into the T-pillars represent constellations, that the vulture and the scorpion, the boar and the bird, are not only terrestrial symbols but stellar ones. The so-called vulture stone, or Pillar 43, stands out. On it a bird holds a sphere in its talon. Beneath it strange symbols cluster, abstract at first glance, but hauntingly deliberate. Could the sphere be the sun, or a comet? Could the vulture be Sagittarius, and the scorpion unmistakably Scorpius? Could the entire scene be a depiction not of myth, but of memory, a memory of something that fell from the sky? It is a wild idea, and yet it echoes. In 2017, a controversial paper proposed that the carvings on Pillar 43 represent a snapshot of the night sky on the day of a cosmic impact, specifically the hypothesized cometary airburst believed by some to have triggered the Younger Dryas. The dating aligns, the symbolism aligns, and while certainty remains elusive, the possibility casts a long shadow. Could it be that the builders of Göbekli Tepe were not merely carving animals, but encoding an event, a message across millennia, etched in myth and stone? If so, then the temple becomes something more, not just a sacred site, but a warning, a monument to the day the sky fell. But how would hunter-gatherers, without writing, without telescopes, carry such a memory? Through story, through symbol, through ritual, across generations, through the rhythms of spoken word and seasonal gathering, the trauma of a vanished age could be passed down, not with precision, but with power. In this light, Göbekli Tepe becomes the physical anchor of an oral tradition so profound that it needed the earth itself to help it endure. Is this how cultures survive catastrophe? By transforming loss into legend? By transmuting fear into faith? And if those carvings speak of stars and fire, what must they have believed about the world above? Did they see the heavens as a realm of gods or of danger? Did they worship what they feared, or fear what they could no longer forget? When knowledge becomes too large for language, do we turn to stone? That seems to be the question Göbekli Tepe silently asks us, buried for millennia beneath a hill that kept its secret so well, even the local shepherds had no idea what they were grazing their flocks upon. And yet, from that very hill, where time folded inward like a palimpsest of worlds gone by, humanity may have chiselled its first true myth into permanence, not in words but in orientation, in animal, in sky. Because the alignment of Göbekli Tepe with the celestial sphere is more than an architectural flourish. It may be a mnemonic, a message encoded in the very heavens. The enclosures seem to frame specific stars and constellations during solstices or key astronomical events. If the builders had watched the skies long enough, across enough generations to predict where the sun would rise and where the stars would fall, then what else might they have seen? What memories were preserved in these patterns? Consider the precession of the equinoxes, a slow, stately wobble of Earth's rotational axis that takes nearly 26,000 years to complete. To observe it, one must track the sky for centuries, even millennia, noticing the slight drift of the stars' positions against the seasonal cycle. Some researchers believe that Göbekli Tepe encodes this knowledge, that the site marks the solstitial alignment of constellations as they would have appeared over 11,000 years ago. If this is true, then these ancient builders were not only survivors, they were skywatchers, historians of the cosmos, archivists of catastrophe. Could the trauma of the Younger Dryas have made them such? Could a brush with extinction have pushed early humans to search for patterns, to beg the stars for answers, to carve the memory of destruction into stone so future generations would not forget? Perhaps this is what sacred means, not just divine, but necessary, not just holy, but vital. Göbekli Tepe might not be a temple to gods, but to survival. Its layers, painstakingly buried by the very people who built it, may be part of a ritual of closure, or a ritual of concealment. What happens when trauma becomes too sharp to live beside? Do you preserve it in ritual and then bury it beneath a hill, hoping the memory will rest until it is needed again? And what of the animals, those carved in sharp relief along the monoliths? They do not prance, they loom, teeth bared, claws out. Some appear decapitated, others swarm. They are not symbols of peace, but of tension, even threat. What story do they tell? A world where the line between human and beast was thin. A world where nature, long partnered in balance, had turned feral. Were these animals real, or remembered shadows of creatures that perished during the Great Dying, symbols of what was lost, or what was feared? Do the animal motifs preserve not just fauna, but feeling? The dread, the awe, the reverence of a world suddenly made strange? When memory decays, what survives in the outline of a fang, in the curl of a serpent, in the wings of a vulture? Yes, especially the vulture. Its presence recurs throughout Göbekli Tepe, dominating pillars, haunting the periphery. In many ancient cultures, vultures are not just scavengers, but sacred intermediaries, creatures that ferry souls from the world of the living to the realm of the dead. In the funerary practices of later Anatolian and Mesopotamian societies, vultures devoured the bodies of the deceased as a form of sky burial. Flesh was given to the air so that the soul might rise. What if this symbolism began here? What if the vulture at Göbekli Tepe was not just a bird, but a messenger, or perhaps a witness? What did the vulture see, circling above the trembling earth during the Younger Dryas onset? Firestorms, ash-choked skies, the slow parade of dying herds. If the people who built Göbekli Tepe believed that the sky had once turned against them, raining fire, shattering climate, casting down the order of things, then the vulture may have become their emblem of transformation. It consumed the old world and watched the new one rise. And in that new world, something changed in humanity. This is not merely the story of a temple, it is the story of a threshold, between Ice Age and Holocene, between chaos and culture, between remembering and myth-making. Göbekli Tepe marks a turning point in human consciousness, when survival gave way to meaning-making, when hunting evolved into ritual, when the world was no longer just lived in, but interpreted. The very act of gathering to build such a site required coordination, belief, purpose. Was this the spark of civilization, not agriculture, but trauma? And still, across the ages, the symbols endure. In other cultures, far from Anatolia, echoes arise, stories of fire from the sky, of floods that swallowed the earth, of beasts that once ruled the land. The myths are not isolated, they are persistent. In Native American traditions, the thunderbird throws down fire. In Mesoamerican tales, the gods destroy the world with celestial flames. In ancient Indian lore, a blazing star brings death. The Norse speak of Fimbul winter, the great bitter cold before the end. And in every corner of the globe there are tales of a deluge, a purging, a restart. Are these coincidences, or are they fossils of memory smoothed by time into story? Oral traditions are not mere fictions, they are vessels. They carry cultural truths encoded in metaphor, wrapped in rhythm, passed from parent to child over unbroken chains of breath. In pre-literate societies, memory was muscle, myth was archive, and the greatest events, those that scarred the earth itself, would not be allowed to die, not if they threatened to return. So what if Göbekli Tepe is not alone? What if other monuments, other stories, other sacred layers exist across the world, each holding part of the same memory, refracted through culture, through distance, through time? Could there be a global memory of a cosmic trauma? still flickering in the legends we once dismissed as fantasy? What happens when we begin to listen to myth as if it were data, as if it were a voice from the deep past, not just singing, but warning? Then suddenly, the world becomes haunted not by ghosts, but by echoes, not by superstition, but by memory trying to survive in disguise. And in the stone rings of Göbekli Tepe, that memory stands upright, 13 feet tall, staring out across time with blank, stylized faces carved into pillars like forgotten gods or ancestral sentinels. These are not idols. They are placeholders for something unspeakable, perhaps the shape of terror, perhaps the shape of reverence, perhaps the line between the two, because it is there, in that uncanny threshold between death and story, that the sacred layer forms. Buried not just in dirt but in consciousness, this layer is both geological and symbolic. It rests between epochs, before and after the fall. Not only in Turkey, but in the black mats of North America, in the soot of the Greenland ice cores, in the scarred rock of South America, and maybe, just maybe, in the rhythmic chant of an elder's story beneath starlight. It is everywhere and nowhere, visible only when one learns to read the earth as a manuscript, and culture as a footnote to catastrophe. In some traditions, myths of fire from the sky are accompanied by tales of rebirth, of golden ages that fell, and new ones that rose from ash. In the Sumerian king list, the reigns before the flood are impossibly long, kings ruling for tens of thousands of years, until the deluge erases time itself and begins again. In Egyptian myth, the Eye of Ra burns the earth in divine anger, but then recedes, giving rise to order and civilization. Again and again we see the same architecture: cataclysm, forgetting, remembering, rebuilding. What if this architecture is not fiction, but template? Göbekli Tepe was eventually buried, not by wind or erosion, but deliberately. Layer upon layer of fill, stone and debris packed into the very enclosures that had once stood open to the sky, as if the memory had served its purpose, as if the sacred message had been spoken and now could rest. Or perhaps, as if it had become too dangerous to leave exposed. What would it mean if a society chose to bury its greatest monument, to turn the sacred into sediment, to silence the message until another age, ours, could unearth it? The sacred layer, then, is not just a metaphor. It is a wound sealed with wisdom. It is a wound sealed with warning. So we return to the stones. We run our fingers across the carved backs of scorpions and vultures. We measure shadows and stars. We match myths with craters and stories with strata. We listen. And in that listening, we begin to remember. Not the details, but the shape. Not the event, but the truth beneath it. Because somewhere deep within us, we still carry the fear of the cold that came too fast, of the sky that turned to fire, of the day the animals fell silent and the earth began again. And when we remember, when we finally understand what the ancients tried to tell us with stone and star and story, we are faced with a choice. Will we heed the sacred layer, or become the next one? Because what followed was not fire or flood, but cold. Cold like a betrayal. Cold like the earth's lungs forgot how to breathe. For over 1,000 years, the Younger Dryas held the planet hostage, dragging it back into a glacial grip just as life had begun to stir from its Pleistocene shell. The thaw had started. The ice was in retreat. Then, abruptly, without warning, winter returned, and it did not let go. What must it have felt like for the people of the Levant, of the Fertile Crescent, to watch the world turn its back on spring? To feel the promise of warmth collapse into frost once again? For generations the land had softened, plants had returned, animals had multiplied. But now the winds howled through parched hills, rains faltered, and the earth cracked beneath the weight of a season that refused to end. And yet, they did not perish. They adapted. In the Levantine corridor, stretching from modern-day Israel through Syria and into the highlands of southeastern Anatolia, human groups had already begun to cluster into more permanent settlements, not because they had to, but because they could. The Natufian culture, ancestors of the first farmers, gathered wild grains, built semi-sedentary villages and watched the stars. They were poised on the edge of transformation. Then came the cold, and the edge became a precipice. Their world withered. The The grasses they harvested grew sparse. Game moved on. And so, these early people faced a choice: follow the food into the unknown, or bring the food to them. What happens when hardship doesn't end? When droughts stretch for years? When the hunger is no longer seasonal but structural? They stayed. And in staying, they began to intervene. First by tending, then by planting. They selected the hardiest barley, the strongest einkorn, the wild wheat that could endure longer under a paler sun. They dug storage pits to hold what could be held. They watched the sky not just for myth, but for signs. Agriculture, that irreversible shift in human trajectory, was not born in abundance, but in crisis. It was an act of desperation turned into design, an adaptation that, once made, could not be undone. And in the Fertile Crescent, where soils were rich and the rivers, Tigris, Euphrates, Jordan, still pulsed through their valleys, a different kind of human emerged. No longer just the hunter, no longer just the wanderer, but the keeper, the cultivator, the one who looked into the mouth of winter and said, "You will not have me, but survival is not only material, it is spiritual." How do you endure a climate that seems to punish life itself? How do you retain meaning when the world forgets to warm? You bind yourselves together, through story, through kinship, through custom, through the slow birth of culture that remembers what the winds try to erase. And in that long winter, something ancient in the human soul woke up. Not just the will to live, but the will to remember. Because survival without memory is merely endurance, and endurance without meaning is despair. The peoples of the Levant and the Fertile Crescent did more than withstand the Younger Dryas. They transformed it into a crucible of invention. Out of the scarcity came structure. Out of hunger, hierarchy. Out of the endless cold, the first fragile warmth of civilization. The Natufians had already gathered wild barley, lentils, and rye for centuries, but the Younger Dryas forced them to reconsider their relationship with the wild. The landscape they had known, the lush, temperate Eden of the late Pleistocene, grew brittle under frost. Forests shrank, rainfall faltered, animals migrated north or perished. Yet the Natufians did something unprecedented. They stayed rooted in place. They built stone houses, circular and communal, and began to shape the earth around them. They did not simply harvest, they began to plan. It was here, in the shadows of hardship, that agriculture was born. Not as a discovery, but as a negotiation. To sow a seed is to gamble against the climate, to bargain with the soil. These early humans did not control nature, they coaxed it. They bent their backs to the rhythm of an untrustworthy sky, and in doing so, they discovered something extraordinary, the possibility of persistence. In the uplands of southern Anatolia, near the future plains of Mesopotamia, they experimented with cultivation. They learned which plants endured cold snaps, which sprouted quickly after rain, which could be stored through the lean months. Bit by bit, they shaped ecosystems around their needs, altering the genetic destiny of wild species. This was not yet the golden wheat fields of Sumer or the irrigated gardens of Babylon. It was smaller, humbler, a scatter of terraces, a few hardy patches of grain clinging to the edges of frost. And yet from those patches came a revolution. For when people began to stay, everything changed. The rhythm of migration, of chase and feast and famine, gave way to a rhythm of seasons. Time itself altered. The human mind began to think in cycles, in years, in futures. They built granaries to hold the promise of tomorrow. They tended to the dead, leaving them in graves beneath the hearth, as if the past itself now dwelled in the home. The cold had bound them, yes, but in binding them it forced a new coherence. They learned to weave community as tightly as they wove their baskets. What if civilization itself is a response to trauma? What if every brick, every ritual, every story began as a way to hold back the ice? And still, the earth did not relent. Winds scoured the plains. The great glacial meltwater floods altered rivers and carved new paths through the land. Food insecurity haunted every harvest. And yet, with each passing century the people endured. Their lives, once dictated by the hunt, were now measured by the seed. The world was unforgiving, but it had given them something deeper than survival. It had given them mastery over adaptation. For to survive 1,000-year winter is not only to persist, it is to reinvent what it means to be human. And in the long shadows of this reinvention, the ancient peoples of the Fertile Crescent began to sow more than crops. They sowed memory. With every generation born into a world that refused to warm, the lessons of survival became ritual, and ritual became culture. It was not enough to endure the cold. They had to make sense of it. And so the cold became a teacher, a mirror, a force that shaped the architecture of their thought. Across the region, archaeologists find the fingerprints of this transformation, not just in tools and seeds, but in symbols. Carved stones bearing the marks of animals, celestial bodies, abstract forms that seem to echo both utility and myth. The invention of agriculture may have anchored the body, but it was story that anchored the mind. These early societies, bound by the rhythm of the seasons and the uncertainty of climate, developed calendars, carved lunar notations into bone, traced the arc of the stars with cautious reverence. They were no longer simply responding to nature, they were trying to predict it. But can you truly predict a world in chaos? The Younger Dryas was a climate of betrayal. Patterns shifted without warning, rains failed, frost returned in midsummer, crops that once flourished withered beneath an unfamiliar wind, and yet this unpredictability did not collapse culture. It forged it. In the settlements of Jerf el Ahmar, Muribet, and Abu Huraira, precursors to the first true villages, we see not the ruins of desperation, but the blueprints of resilience. Storage bins, communal buildings, grinding stones worn smooth by years of use. These people were not passive victims of climate. They were negotiators of change. And within this negotiation, the first spiritual structures took root. Perhaps not temples in the modern sense, but shared spaces marked for ritual, gathering, reflection. In these spaces, the community became more than a survival strategy. It became a soul, a memory engine, a shelter not only for the body, but for the fragile narrative of who they were, where they had been, and what had almost destroyed them. Could this be the origin of myth itself? A people reaching beyond the veil of the present, pulling forward the voice of ancestors who remembered the last warmth, who had walked beside mammoths and seen the stars fall. Was myth born not from ignorance, but from memory strained by grief? And if so, then every hearth in that long winter became a kind of altar, every seed a prayer, every return of the sun a holy reckoning with a world that had once tried to erase them. The cold did not simply freeze rivers or still the grass, it slowed time itself. It stretched lifespans into lineage, years into epochs. It asked, "What will you become if the world never softens?" And their answer was quiet, but powerful. They became human beings who remembered forward, because to remember forward is to live not just in the aftermath of crisis, but in its shadow, in its rhythm, in its prophecy. The cold did not only bind the earth, it bound the mind. It etched itself into the architecture of thought, into the cadence of story, into the very language of caution passed from elder to child. The stories they told were not mere legends, they were instructions, warnings, blueprints of how to live when the seasons cannot be trusted. And in the stories, winter always returned. This is how resilience becomes ritual. You begin to structure your society not around abundance, but around interruption. You expect failure, you prepare for hunger, you teach your children not that spring is promised, but that it must be earned. Even the early agriculturalists of the Neolithic were not naive farmers. They were survivors still haunted by collapse. They built redundancy into everything: surplus grain for lean years, storage for the unexpected, mobility as an option even amid sedentism. Adaptability was not a trait, it was a creed. And so we see the rise of hybrid lifeways, semi-nomadic patterns, settlements with seasonal migration, hunting that continued alongside planting. These were not the sudden birth pangs of civilization, but cautious steps along a frozen river that could crack at any moment. In the Jordan Valley, at sites like Ain Malaha, people constructed stone houses and cultivated cereal grains, yet continued to fish and forage. They were building something new, yes, but not in certainty, in vigilance. And vigilance is a kind of intelligence, an awareness that the earth remembers, even when we do not. The Younger Dryas taught humanity a cruel wisdom, that warmth is temporary, that plenty is fragile, that nature does not owe us kindness. But it also taught something deeper, that meaning is forged in the crucible of hardship, that the stories we cling to in the longest nights become the architecture of the world we build when the sun returns. What happens when you live in the echo of a 1,000-year winter? You learn to value continuity over conquest. You build bonds that transcend blood. You bury your dead with care, not just to mourn them, but to anchor yourself in time. You shape your gods not as saviours, but as cycles, forces that die and rise again, like the barley, like the moon, like the sky after fire. The first religions may not have asked for dominion. They may have begged only for memory, for signs that the world would not betray them again. And so from cold came compassion, and from hunger came humility. This is not the story we usually tell about our origins. We speak of the Neolithic Revolution as triumph, as mastery of nature, as the beginning of progress. But perhaps that story is upside down. Perhaps it was not mastery, but surrender. Not progress, but protection. Not domination, but devotion. To each other, to the earth, to the past. How else does a species survive a climate of loss? By making meaning out of every breath it is allowed to keep. And in that breath, carried across 1,000 years of chill and struggle, the first seeds of what we now call culture were planted. Not in fields, but in minds shaped by frost, in hearts tempered by absence. These were not just survivors of the Younger Dryas. They were its interpreters. They were the ones who stayed awake while the earth slept, who kindled fire not merely for warmth, but for remembrance, for transmission. For the long thread of continuity that would one day become us. The legacy of the cold is not just found in ruins and carbon layers, it is encoded in us, in how we gather, how we plan, how we fear the unexpected, how we prepare even when we cannot predict. The long winter etched itself into our species as surely as it sculpted river valleys and shifted weather patterns. It gave us our first sense of history, not as a distant past, but as a living inheritance. Because long winters require long memories, this is why stories stretch back beyond what writing remembers, why flood myths echo across cultures, why tales of burning skies and endless frost persist from Mesopotamia to the Arctic. These are not inventions, they are cultural fossils compacted through centuries of repetition, layered like geological strata. They may no longer point to specific dates, but they still point to the truth, that we came through something, and we built ourselves in the aftermath. The end of the Younger Dryas did not come gradually. It broke as abruptly as it began. Temperatures surged, ice retreated, rivers roared, the earth stirred once more. But the people who emerged were not the same as those who had entered the freeze. They were organised, rooted, sacred. Their children had never known a world that was not broken, and so the world they rebuilt bore the mark of those fractures. Agriculture accelerated, settlements grew, gods took on forms moulded by fear and reverence. The earliest cities, the earliest kings, the earliest empires, they did not sprout from nowhere. They grew from cold soil tilled by ancestors who had endured centuries of uncertainty. They grew from the quiet heroism of those who had not fled the frost, but learned to speak its language. What binds us to each other, across time? It is not only blood, it is not only language, it is a shared inheritance of survival, a recognition buried deep in our bones that we are here because someone once kept a fire going through a winter that would not end. The Younger Dryas was not merely a climate event. It was a crucible, a forge in which humanity was pressed, cooled and reshaped. And though the ice has long since receded, the shape it gave us still lingers, in our fears, in our rituals, in the very architecture of civilization. What must it have felt like to wake on the first true day of spring after 1,000 years of cold? Perhaps they didn't rejoice. Perhaps they simply exhaled, quietly, together, and began to remember forward once again. Because when Earth awoke, it did so not with hesitation, but with a roar. The long cold relinquished its grip as suddenly as it had seized the planet. Temperatures surged, by several degrees in mere decades. Ice sheets, once stoic and sprawling, collapsed at their edges. Glaciers retreated not in centuries but in generations. Forests reappeared. Rivers swelled. The air shifted from brittle silence to the scent of thawing earth and flowing water. The earth was no longer holding its breath. It was inhaling. And yet, what must it have felt like to witness the reversal of an age? For generations the sun had betrayed them, crops had failed, snow had lingered in valleys it did not belong. Then, as if a spell were broken, the warmth returned, but not gently. It was not the tentative spring of a normal year. It was a tidal wave of life racing to catch up with itself. In Greenland, ice cores record the shift with brutal clarity, a near-instantaneous leap in temperature, locked in isotopic signatures that whisper of planetary transformation. This was not just change, this was upheaval. The Younger Dryas ended not in slow retreat, but in sudden surrender. Some scholars estimate that temperatures in parts of the northern hemisphere rose by as much as 10 degrees Celsius in under a century. That is not weather. That is revolution. But revolutions do not only reshape landscapes, they reshape minds. The people who had endured the long freeze now stood on the trembling edge of a new world. Their children would never know the same hunger, the same cold, the same stillness. But they would carry its echo in their bones. The trauma of the Younger Dryas did not vanish with the snow. It lingered, encoded in ritual, in memory, in the architecture of early societies that emerged in its wake. What does it mean to be born after catastrophe? To inherit a world transformed, but shaped by the fears of those who came before? The climate surged forward, but humanity looked backward, and in that backward gaze they began to build, not only homes, but meaning. They had lived through the silence. Now they would speak. Across the Fertile Crescent, settlements grew larger. The Natufians gave way to the pre-pottery Neolithic cultures. At Sionu, at Jericho, at Nivali Chori, we find the first evidence of structured villages with communal buildings, storage facilities, and for the first time, symbols etched into walls and shrines. These were no longer just adaptive clusters of survival. These were the seeds of civilization blooming in the warm light of return. But even as the land softened, even as wild grasses gave way to domesticated grain, the memory of instability did not fade. It became part of the pattern, a cultural reflex, a quiet murmur beneath every harvest. Remember the ice. Because when Earth awakens after sleep, it does not always rise gently. Sometimes it stirs with fire in its veins. The end of the Younger Dryas was not just a thaw, it was a release. The ice that had gripped continents for millennia now melted in torrents. Rivers that had been sluggish under frozen weight thundered anew. Sea levels surged as meltwater cascaded from retreating glaciers into oceans that rose by meters within human memory. The Earth, once rigid and breathless, now flexed and sighed and exhaled its pent-up warmth, and as the planet transformed, so too did its inhabitants. The descendants of those who had endured the 1,000-year cold awoke to a world that seemed almost too alive. For them, the sudden fertility of the land was both a gift and a shock. Grasslands burst into forests. Once barren valleys filled with herds. Lakes bloomed with fish and fowl. The rhythm of scarcity that had defined generations shifted overnight into one of abundance. But abundance carries its own dangers. To those shaped by famine, too much can feel like temptation, unreliable, treacherous. And so, while the climate softened, humanity's relationship with it remained wary, almost reverent. They had learned that the earth could turn in an instant, and that knowledge became a kind of faith. The first true Neolithic societies rose from this ambivalence. At Jericho, one of the oldest continuously inhabited settlements on Earth, people built massive stone walls around their village, not to keep out enemies, but perhaps to keep out memory. The great tower of Jericho, rising from the desert floor like a petrified echo of the Ice Age, seems less like a fortification than a monument, a declaration that humanity had survived the betrayal of nature and would not be caught unprepared again. Everywhere across the Fertile Crescent, the signs of transformation multiplied. Grain cultivation became systematized. Barley, einkorn, and emmer wheat, once the fragile experiments of Natufian foragers, became the foundation of agricultural life. Goats and sheep, once hunted, were tethered. Dogs had already become partners, but now they were family. Villages expanded into proto-cities with plazas, shrines, and organized labor. The rhythm of the hunt was replaced by the rhythm of the harvest. But even amid this burst of innovation, there was unease, an echo of the cold that refused to melt. The stories passed down by the elders spoke of the time when the sky darkened, when the rains ceased, when the world itself turned hostile. Those who had survived told their children, never take warmth for granted. And so the Neolithic mind grew in two directions at once, one toward creation, the other toward caution. And perhaps this tension, the joy of rebirth bound by the memory of loss, is what made the first civilization so enduring. They built not just to live, but to remember. They raised temples not only to gods, but to the lessons of the ice. For they knew that warmth, too, is a kind of test. It tempts us to forget. It invites us to believe the world is stable. But Earth had already shown them the truth. Balance is temporary. And the wise never stop preparing for winter, even when the flowers bloom. That wisdom, born of hardship and etched into the psyche of early Neolithic communities, shaped how humanity stepped into its first sustained relationship with abundance. The world was changing fast, faster than ever before in human experience, and while the land healed, grew lush, and opened its arms to cultivation, the people did not forget what lay beneath the surface. The ice had taught them that the earth's kindness was not guaranteed, and so they moved cautiously through their newfound prosperity, turning memory into architecture, trauma into ritual, and vigilance into permanence. Consider the villages that sprang up during this transition, Çatalhöyük in Anatolia, a dense honeycomb of mud brick homes stacked wall to wall, where people walked rooftops instead of streets and buried their dead beneath their floors, each house a mausoleum, each hearth a link between ancestors and descendants. Why build this way, unless home itself was now sacred? Unless every structure was a response to instability, a promise that shelter would never again be taken for granted. Here, early humans developed more than tools and farming. They developed continuity. They wove the past into the present with obsessive care. Wall paintings in Çatalhöyük depict bulls, leopards, volcanic eruptions, memories of violence held close, painted not for art but for remembrance. Was the image of a mountain spewing ash a memory of eruption, or a metaphor for the sudden violence of environmental upheaval? Was it both? As Earth's climate stabilized into the warm Holocene epoch, human population expanded rapidly. In Europe, forests thickened and drew in waves of human migration from the Near East. In Africa, the Sahara transformed into a lush savanna, inviting seasonal migrations and early pastoralism. In Asia, the monsoons returned with vigor, reviving the great rivers of the Indus and the Yellow. Across every continent, humans surged into new niches, but they did so with caution, and the memory of collapse folded into their movements like a sacred text. Because behind every seed planted was a question: what if it happens again? And so they built redundancies. They stored grain not just for seasons, but for years. They honoured ancestors not merely out of sentiment, but out of strategy. Their stories were warnings. Myths and origin tales, once dismissed as fiction, now appear to be memory fragments encoded in symbol. Sky serpents, earth gods, fire-wielding spirits, all possible metaphors for cataclysm remembered, reinterpreted, retold. When Earth awoke, it gave humanity an opening, but not a blank slate. The landscape bore scars, riverbeds redirected by glacial floods, valleys still raw with meltwater, soils reshaped by erosion and rebirth, and humans too bore marks of what they had endured, not on their skin, but in their social DNA, in the way they organised labour, trusted elders, built into the earth rather than above it, because to live after the Great Cold was to live in the shadow of its return. And if warmth was a blessing, then memory was its price. This memory, sometimes vivid, sometimes buried, travelled not only in story and architecture, but in the very roots of human expansion. As the Holocene stabilised, the world became a garden of opportunity. Forests marched across Europe, deserts retreated, ice gave way to meadows. Humanity, long constrained by climate, was suddenly released from its cage, and with that release came movement, a great dispersal, not chaotic, but pulsing, deliberate, like a breath held for too long finally let go. From the Levant and the Anatolian highlands, early Neolithic societies began to spread, carrying with them their grains, their animals, their memory. The great wave of farmers moved slowly into Europe, reshaping the continent not just ecologically, but ideologically. They brought a new way of living: permanence, planning, hierarchy, ritual. The world they had built under the pressure of the Younger Dryas became a model exported across thousands of miles. It was not merely migration, it was transmission. But the Earth, always watchful, was not finished shaping them. As the ice retreated and the ocean swelled, coastlines were redrawn. Lands once walked were drowned. The English Channel swallowed Doggerland, a vast plain that once connected Britain to mainland Europe. Forests disappeared beneath salt water. Camps and hunting grounds vanished beneath waves. The people who lived there did not forget. The deluge became legend. Flood myths began to appear in cultures far removed from one another, in Mesopotamia, in the Mediterranean, in the highlands of India, among Aboriginal peoples in Australia. The details differed, but the shape remained. A world lost, a waterline rising, a memory that refused to sink, and still they moved forward. The Holocene warmth gave rise to abundance, and abundance gave rise to complexity. Villages became cities. Cities grew into networks. The great river civilizations, Tigris, Euphrates, Nile, Indus, Yellow, emerged like green threads stitched across a previously frozen canvas. But beneath their temples and granaries and ziggurats, the long shadow of the Younger Dryas still flickered. These were not cultures born from innocence. They were born from adaptation, from trauma, from resilience so embedded that it became indistinguishable from faith. What happens when you build a civilization on top of a warning? You create calendars not to mark days, but to anticipate disruption. You watch the skies obsessively. You tell your children to pay attention to the patterns in the wind. You mark eclipses and solstices and comets. You listen for the Earth's heartbeat, not because it comforts you, but because it once stopped. And in this listening, science was born. Astronomy, irrigation, engineering. None of these were accidents. They were strategies against forgetting, against another collapse. Civilization was not an end. It was a defense. Because the Earth had awoken once before without warning, and while it had given humanity a second chance, it had not promised a third. So the people who thrived in the warmth did not ask, "What now?" They asked, "What next?" Because to live in the aftermath of calamity is to live in expectation of its return. Even as the earth bloomed and the sun cast longer shadows over fields of barley and stone-cut temples, the question hummed beneath every innovation: would the sky fall again? Would the cold return? Would the fire? In this anxious fertility, humanity expanded, but always with one eye over its shoulder. And yet, that vigilance bore fruit. What might have been a lingering wound became instead a foundation. The very systems designed to prevent collapse became the engines of human expansion. Surplus storage became trade, seasonal planning became calendars, communal effort became governance. Each adaptation honed during the Younger Dryas transformed into a pillar of civilization. It was not just survival, it was synthesis. Long-term climate data shows that the Holocene period following the Younger Dryas was remarkably stable, an unusual calm in Earth's volatile climate history. This climate plateau lasted for thousands of years, creating a greenhouse of possibility. From it rose the structures of our modern world. But even this golden window was shaped by the trauma that preceded it. The resilience of early Neolithic societies became the template for later empires. Their caution became our complexity. And yet, even today, echoes of that ancient shift ripple through us. The very idea of progress is steeped in the assumption that stability is rare and must be engineered. The obsession with order, forecasting and control, these are not quirks of modernity. They are inherited instincts, passed down from ancestors who learned to farm with one hand and scan the horizon with the other. The agricultural revolution was not the end of fear. It was fear transformed into preparation. We see the fingerprints of the Younger Dryas not only in ruins, but in rituals, not only in climate records, but in cultural memory. From the sacred calendars of the Maya, to the flood myths of Mesopotamia, to the taboo systems of Polynesian navigators, there lingers a reverence for the planet's power to turn, and to turn quickly. Earth is not a passive stage. It is an actor in the human drama, with moods, rhythms, and unpredictable monologues. And now, in our own time of shifting climate and melting ice, the parallels grow sharper. The story of the Younger Dryas is not a closed book. It is a mirror, a warning, a whisper from deep time. You've been here before. The Earth once slept, then it changed its mind, fast, without apology. But if our ancestors could adapt in caves, in stone-ringed farms, in trembling river valleys, then perhaps their wisdom still walks with us, not in prophecy, but in preparedness, not in fear, but in understanding that the Earth will change again. And when it does, those who remember will shape what comes next. Because when Earth awoke the first time, it gave us more than another chance. It gave us the blueprint for remembering how to begin again. It did not whisper, it screamed, frozen in silence for millennia, until the ice itself began to weep. Beneath layers of snow, beneath strata of carbon-rich sediment and the tangled bones of lost giants, the message was buried. And when it finally emerged, it did so not with words, but with temperature curves, pollen counts, and isotopic anomalies, language spoken in degrees and dust, the Younger Dryas, a flash freeze that took a warming world and locked it once more in frost, a global convulsion, as if the Earth had changed its mind mid-thaw, as if something deep within the planet had panicked, recoiled, reversed. It had lasted just over 1,000 years. Then, just as abruptly as it had begun, it was over, but the warning remained. What kind of world can change that fast? What system, so vast, so ancient, can shift its rhythm in mere decades? And more haunting still, could it happen again? Today, we find ourselves staring down a mirror. Not an icy one this time, but a scorched and rising tide of the heat. The graphs we draw today look eerily familiar to those carved in ice cores from Greenland, from Antarctica, from the buried memory of Earth itself. Sharp inclines, rapid changes, a climate accelerating beyond its bounds. But this time, the direction is not cold, it is fire, and the trigger is not unknown, it is us. Yet there's a strange symmetry in the shape of the curve, in the slope of catastrophe. When scientists compare the rate of warming at the end of the Younger Dryas to the present day, the contrast is alarming. That ancient world warmed as much as 10 degrees Celsius in a matter of decades, and yet even that was a natural event. Today, we are orchestrating a similar rate of change, but we're doing it not from cosmic accident, but from choice, industry, and neglect. We are pressing on the same nerve that nature once struck by surprise. What happens when the source of instability is not the cosmos, but the mirror? The Younger Dryas has become a Rosetta Stone for climate science, a benchmark for understanding how fast the Earth can change, how fragile its balances are, how sensitive its feedback loops. But it is also a parable, a dark fable encoded in geology, because in its aftermath, everything changed. Not just temperature, but life itself. Ecosystems were shattered, species erased, cultures vanished or were forced to adapt with breathtaking speed. If a mere pulse of meltwater could do that, what does our age of fire promise? We peer back through time, not out of curiosity, but out of urgency. In the silt of ancient lakes, in the soot of black mats, in the pollen counts of vanished forests, we are reading our own obituary and draft, or perhaps our rescue instructions, because the past is not just prologue, it is a rehearsal, and we are mid-scene. The Earth, it seems, is a master of repetition. Its catastrophes do not occur at random, they follow a rhythm, a deep geological pulse that hums beneath the centuries. But unlike a metronome, its beat is unpredictable, its tempo erratic. The Younger Dryas was one such staccato, a violent pause between verses. Today, as the ice melts once again, the refrain begins to sound familiar. We are told that history does not repeat itself, but in the language of the planet, it often rhymes. The modern warming trend bears the same curve of acceleration, the same tipping point signatures seen in ancient ice. Carbon spikes, oceanic shifts, feedback loops beginning to spiral. The difference is not in the pattern, but in the cause. Then, nature acted alone. Now, we have joined as co-author and antagonist. The scientific community too finds itself haunted by the Younger Dryas. It was once a mystery wrapped in contradictions, a sudden cold spell interrupting the steady end of an ice age, triggered by what? For decades, the answer oscillated between theories like a pendulum. Meltwater floods from Lake Agassiz disrupting the Atlantic circulation. The collapse of the Amok, the ocean's great conveyor belt, stalling warmth from reaching the north, volcanic aerosols, solar shifts, and most controversially an extraterrestrial impact, a comet shattering in the sky, seeding continents with fire and ash. The evidence remains scattered, contradictory, and fierce in debate. Some geologists point to microspherules and platinum anomalies, tiny glass beads, melted from unimaginable heat. Others dismiss them as natural byproducts of Earth's restlessness. The black mats, those carbon-rich seams marking the onset of the Younger Dryas, are both evidence and enigma. Soot from global wildfires, or organic decay from flooding plains. It is here, in this crucible of uncertainty, that science most resembles myth. Competing narratives, each grounded in evidence, each incomplete, each reflecting, in its own way, the limits of our knowing. But perhaps that's the lesson the ice is teaching, that the Earth's systems are so entangled, so alive, that even now, with satellites and supercomputers, we can only glimpse the outline of cause and effect. The Younger Dryas reminds us that the planet does not always reveal its logic. It acts, then lets us argue about why. And so the debates persist, not just in conference halls but in philosophy itself. Was the Younger Dryas an accident, or an act of regulation? A violent correction in Earth's metabolic cycle? Could it be that our planet behaves not merely as a sphere of matter, but as something closer to a living organism, one that seeks equilibrium even if it must destroy to achieve it? If so, what does that make us? Cells of the body, or symptoms of its fever? Because if the Earth has memory, and every core sample suggests it does, then the message buried in the melt is not only a record, it is a warning system, and like all warnings, it can be ignored until it cannot. We live in a civilization that prides itself on foresight, on its ability to model, predict, and act. But in many ways, we are no different from the early Holocene people standing at the edge of a retreating glacier, unsure whether it would advance again or finally die. The difference is, they didn't cause the thaw. We are the architects of ours. This realization, that we are not merely witnesses but agents of planetary change, has fractured the scientific discourse into new territories. It is no longer just about understanding what happened in the past, but about confronting what we are doing in the present. The Younger Dryas once served as a cautionary tale about how fragile Earth systems could be. Now it has become a baseline, a benchmark against which our current rate of change is measured, and disturbingly we are outpacing it. The temperature spike that ended the Younger Dryas took decades, maybe less than a century. In our current trajectory, we are matching that pace, only this time there is no glacial dam breaking or comet fragment exploding above the Arctic. It is emissions, cities, consumption, and the endless churn of fossil-fueled ambition. We are triggering feedback loops we do not fully understand. Permafrost melt releasing methane, dying forests no longer sequestering carbon, ocean currents beginning to wobble like tired gears in a machine. Scientists are no longer just debating if, they are debating when. When will the Atlantic meridional overturning circulation weaken beyond return? When will the Antarctic ice shelves reach their fracture point? When will the Amazon flip from rainforest to savanna? These are not doomsday speculations. They are projections based on data, logic, and a grim familiarity with how fast things can unravel. Yet amid this uncertainty, one truth grows louder. The Earth has done this before. Not identically, not by human hand, but with equal ferocity. And in its ancient trauma lies a kind of guide, not in preventing the change, perhaps, but in surviving it. The philosophical implications of this are profound. If Earth is, as James Lovelock proposed, a self-regulating system, Gaia, then what role do we play in its balance? Are we the bacteria in the bloodstream, or the immune response gone rogue? Can a species intelligent enough to read the ice also be wise enough to heed its message? And what if we aren't? That's the haunting power of the Younger Dryas. It does not resolve. It leaves behind sediment and mystery, pollen and paradox. It dares us to interpret the silence, to translate geology into prophecy. It says, "This happened without you once. Now it is happening with you. Choose what part you wish to play." Because the planet does not forget. It recalibrates, not out of malice or mercy, but out of necessity. The Earth is not a machine we can program, nor a stage we simply perform upon. It is an actor in its own right. Ancient, sentient in systems if not in mind. relentless in its pursuit of equilibrium. When its balance is broken, it does not negotiate. It compensates. That compensation may come as flood or fire, drought or deep freeze. The Younger Dryas taught us that Earth has levers we barely understand. It can stop ocean currents. It can blacken the sky. It can take warmth from the air, life from the soil, and still march on, indifferent to the stories that vanish in its wake. And yet, for all its power, Earth has always offered signs. The melt layers of Greenland's ice sheets are not just remnants of heat. They are punctuation marks in a long, cold sentence. Volcanic ash frozen into cores, beryllium isotopes marking solar activity, dust bands speaking of ancient winds. These are the Earth's marginalia, the notes in its margins, left for any species willing to read. We have become, perhaps accidentally, readers of this vast text. Paleoclimatologists, geophysicists, glaciologists, they are its translators. And what they tell us, over and over, is that the story we are living has been lived before, in other keys, but never with a narrator as loud as us, never with a protagonist so close to rewriting the ending. Philosophically, this places humanity at a unique inflection point. We are no longer just biological creatures shaped by nature. We are geological agents reshaping the planet itself. The Anthropocene is not a metaphor. It is a stratigraphic fact. Future civilizations, if they exist, will find our fingerprints in layers of plastic, concrete, soot, and radiogenic isotopes. Our story is already fossilizing. And here the message of the Younger Dryas sharpens. It says, change comes swiftly. No warning is ever loud enough. The Younger Dryas was not a slow drift. It was a veer off the road. An overcorrection so violent that ecosystems flipped, cultures cracked, and the course of evolution itself shifted. We should not expect gentle warnings now. Indeed, many argue we have already entered our own version of tipping points. Ice is melting not linearly, but exponentially. Feedbacks are activating, coral reefs bleach, then die. Forests burn in places once soaked with rain. Migration patterns, of animals and humans, begin to shift in response, and still we hesitate. We argue over cause, over models, over how much is natural versus anthropogenic. But while we debate, the planet simply responds. It doesn't care who is to blame. It only cares about balance. So what does it mean to live within a recalibrating world? Perhaps it means we must stop seeing the Earth as enemy or victim, and instead see it as a mirror. A living document, a co-author in a book we cannot write alone. Because if we fail to read the message in the melt, we may become the next footnote, not a grand chapter, not even a tragic arc, just a brief, bewildering blip in the stratigraphy, marked by chemical residue, fractured bones, and the vanishing of noise. Civilizations have fallen before, but never with such global reach, never with satellites watching the sea levels rise, never with climate models flashing red, never with ice, quite literally, whispering, "You've seen this ending already." And yet, hope is a stubborn species. Even in the wake of the Younger Dryas, new life surged. Neolithic cultures bloomed along the rivers once fed by glacial melt. Agriculture arose not because the world was easy, but because the world demanded adaptation. The trauma of the cold may have carved deep scars into memory, but it also laid the foundation for resilience. Fire came, and still we planted. Ice retreated, and still we built. We are descendants of survivors. If there is a wisdom to be drawn from the Younger Dryas, it is not merely scientific, it is existential. The climate is not a background setting. It is a force. It shapes stories before ink is ever laid to page, and in this age, it has become the protagonist again. Our challenge is not only to stop accelerating the damage, but to relearn how to listen, to ice, to soil, to silence. Some scholars are beginning to explore this idea more deeply. Earth not as object, but as subject. Gaia not just as metaphor, but as model. What happens when we shift from managing the environment to participating within it? When we move from dominance to dialogue, it's not mysticism, it's survival. Already new frameworks are emerging: regenerative agriculture, carbon capture rooted in natural systems, architecture inspired by biological principles. legal rights being granted to rivers, to forests, to glaciers. These are not fringe ideologies. They are the beginning of a necessary reframing, and the Younger Dryas, still frozen in time, urges us forward. It says, "I have seen collapse, I have held extinction, but I have also seen rebirth. I remember both." The final question is not what the planet can endure, but what we can become in response. Will we remain creatures of fire, melting every threshold we touch, or can we become stewards of the long memory, readers of sediment, students of sky? Because the Earth remembers, it remembers the comet and the flood. The silence of the mammoth and the scream of the wind, the hands that carved temples as the cold retreated, and the seeds planted in uncertain soil. It remembers the first warmth that followed, and now it remembers us. We are not just part of the story, we are the next authors. The pen is melting in our hands. The past is never truly gone. It lingers beneath our feet, crystallized in ice, hidden in mud, carved into stone. It breathes through the memory of glaciers and speaks in the language of isotopes and dust. It hums beneath our myths and echoes in the oldest stories we have ever told. And if you listen closely enough, you can still hear it murmuring. Because Earth does not forget. It remembers in layers. How does a planet remember? Not with thought, not with emotion, but with record. Every snowfall pressed into a polar ice sheet becomes a page in Earth's diary, storing the chemistry of air, the breath of volcanoes, the whisper of solar winds. Trapped bubbles of ancient atmosphere allow us to read the moods of millennia, their carbon and methane ratios telling of warmth and frost, of bloom and retreat. In Greenland and Antarctica, these frozen scrolls lie stacked upon each other, year after year, like the rings of a silent bell still vibrating from the last toll. And beneath the oceans, sediments fall like silted time. Grain by grain they collect the bones of plankton, the soot of fires, the trace minerals of ancient rivers. These beds of quiet accumulate the violence of eons, tsunamis, droughts, extinctions, blooms, and hold them, unread, until the right questions come along. In these sediments, we find the black mats of the Younger Dryas, the telltale fingerprints of sudden change, the carbon signatures of burning skies. But Earth's memory is not limited to geochemistry. It is also encoded in symbol, in story, in the sacred breath of myth. Long before we had thermometers or satellites, we had tales, stories of floods that swallowed mountains, of stars that fell like fire, of long winters that devoured the sun. These were not fabrications, but interpretations, attempts by frightened witnesses to comprehend what had changed and why it had turned against them. What if those myths were not fiction, but fragmented memory? Is it so hard to believe that memory can outlive its language? Consider the cave walls of Lascaux and Chauvet, painted with animals not simply as art, but as invocation, as preservation. Consider the Vedic hymns or Sumerian epics, coded with astronomical cycles, perhaps anchoring celestial rhythms to the pulse of human life. Consider Göbekli Tepe, rising from the Anatolian soil not as a village, but as a vision. Pillars carved with creatures and stars, placed by hands that had seen the world fall and were trying, desperately, to anchor it in place. Even oral traditions from indigenous peoples across continents speak of times before the world became as it is, times of upheaval, of skyfire, of darkness. How many of these myths, dismissed for centuries as allegory or superstition, might now be reread as memory, misfiled? If Earth remembers, then we are the inheritors of that memory, and the Younger Dryas, with its sudden ice and silence, was not merely an event. It was a story etched in every medium the planet could muster, in glacial breath, in soot-black soil, in whispered warnings passed from fire pit to fire pit. And the question becomes, do we remember how to read it? For thousands of years, the memory of the Younger Dryas has slept in both science and story. We have uncovered its traces, measured its isotopic fingerprints, and argued endlessly over its cause. But beneath the data lies something deeper, a planetary recollection of trauma. The Earth does not remember in words. It remembers in rhythm, in cycles of collapse and renewal, freeze and thaw, silence and sound. In the ice, the story is told through chemistry. A spike in deuterium here, a drop in oxygen 18 there. The patterns are unmistakable. around 12,800 years ago. The smooth arc of post-ice age warming suddenly faltered, like a heartbeat skipping in panic. Temperatures plunged, dust storms swept continents, pollen records show forests retreating and tundra reclaiming their place. Then, 1,000 years later, as quickly as the chill came, it vanished again. Warmth surged back, and the Holocene dawned. This rhythm, the shock, the pause, the rebound, feels almost organic, as though the planet exhaled too sharply, then caught itself gasping for balance. And maybe that's exactly what it did. Sediment cores from lakes across North America, Europe and Asia all tell the same tale. Layers rich in charcoal hint at fires that swept entire ecosystems. Beneath them, carbon-depleted bands mark years when life seemed to hold its breath. In these alternating layers, black and pale, life and stillness, Earth recorded its own fever chart. And in those ashes, humanity's future was seeded. But the most haunting memories are not in the rocks. They are in us. They survive in the collective subconscious, in the myths we carry without realizing their origins. Across cultures, there are echoes of the same refrain: an age of cold, a sun that dimmed, a sky that burned, a deluge that followed. From the Finnish Kalevala to the Hopi stories of the Fourth World, from Mesopotamian flood myths to the Norse Fimbul winter, humanity's oldest tales are not simply moral parables. They are geological records, encoded through metaphor, shaped by fear, and carried forward by faith. And like the glaciers, these stories preserve more than just the event. They preserve emotion, the terror of losing the sun. The awe of watching fire fall from the heavens, the grief of seeing animals vanish that had always been there. Memory does not only store fact, it stores feeling. Perhaps that is why myth endures longer than monuments. Stone erodes, ice melts, archives burn, but story flows from voice to voice, generation to generation. It changes, but it survives. And maybe that is how Earth ensured that its memory would not be lost, not just in ice and soil, but in us. Because when we dream of the end of the world, we are not imagining, we are remembering. And when we remember, we are decoding the long echo of the planet's mind. To frame the Younger Dryas as a catastrophe is only one lens, one shaped by loss, trauma and collapse. But step back, widen the aperture, and another possibility comes into focus. What if it was not a breakdown, but a reset? Not a failure of the planetary system, but a correction. Abrupt, brutal, but necessary. This is not to dismiss the suffering it caused, nor to glorify its cold logic. It is simply to ask, what if Earth did what it had to do? In complex systems theory, there is a term, regime shift. It refers to a sudden change in the structure and function of an ecosystem, triggered when thresholds are crossed and feedbacks intensify. The Younger Dryas was a planetary regime shift, and like all such shifts, it did not occur randomly. It followed patterns, fractal-like, recurring, emergent from chaos. Look closer, and those patterns begin to surface everywhere. In the cooling, we see an overcorrection to sudden warming, perhaps a massive pulse of glacial meltwater into the North Atlantic, perhaps the shockwave of a cosmic airburst, perhaps both. In the aftermath, we find ecosystems rebuilding not identically but differently. Species vanished, yes, but niches reopened. Forests returned in new configurations. Human societies adapted, evolved, even invented. The Fertile Crescent, cradle of agriculture, surged to life just after the Younger Dryas ended. Coincidence or consequence? Was agriculture a human innovation or a planetary necessity? The very trauma of the cold may have forced sedentism, sparked invention, driven collaboration. Even Göbekli Tepe, that ancient riddle of carved limestone and celestial alignments, seems to rise like a scar over the wound. Built in the wake of the Younger Dryas, it is not a village, not a fortress, not a tomb. It is something else. A response, a memory anchor, a sacred mechanism for retaining order in a world that had so recently come undone. To see the Younger Dryas as a planetary correction does not mean it was gentle. Corrections rarely are. A fever is the body's defense, not its illness. An avalanche is not evil, it is motion, release. Earth's systems, interconnected and interdependent, seek balance over time. And when pushed too far, too fast, they do not plead. They shift. This idea, unsettling though it may be, carries implications beyond science. It echoes into philosophy, ethics, and even theology. What is our role in a world that self-regulates with such violence? Are we merely passengers, subject to its whims, or are we now agents, capable of either triggering or tempering its feedbacks? The story of the Younger Dryas is not just about a past event, it's about our present blindness. For in our own time, the climate is again destabilizing. The system is again wobbling. And just like before, there will come a point, not announced, not polite, when the shift will happen, not with fanfare, but with finality. And if Earth is again approaching that edge, the memory of the last correction is not just a warning, it is a prophecy. The sediment does not lie, nor does the ice. They hold no ideology, no agenda. They are not partisan. Their layers are slow testimonies to balance broken, to chaos revisited, to the fact that the planet will not wait for us to debate its condition. When the tipping points are reached, when thresholds shatter, Earth responds, and it does not ask permission. But in this precarious present, we are more than passive witnesses. We are agents. The Anthropocene is not a geological epoch we simply inhabit. It is one we are actively shaping, and that gives our decisions an immense gravity. Here, at the edge of our own climate spiral, we must ask, what are we choosing to forget? We forget that climate is not linear, that Earth does not warm or cool politely. It lurches, it stutters, it lashes back. We forget that systems can flip, abruptly, irreversibly, because they have before. We forget the black mats, the extinction layers, the sudden vanishing of cultures like Clovis or the Megafauna they hunted. We forget above all that Earth has already written this story once. But even amid this forgetfulness, memory persists. It persists in the ice shelves groaning as they carve into the sea, in the permafrost melting to release ancient gases, in the coral reefs bleaching like bones. It persists in the data, but also in the deep time stories, the myths whispered under starlight, the songs that speak of long winters and burning skies. And now, more than ever, we're beginning to read these old memories anew. Scientists analysing ancient climate records speak now of abrupt change, not as anomaly, but as norm. Entire disciplines, paleoclimatology, Earth system science, climate archaeology, have emerged to reconstruct the past and find patterns in its wreckage. At the same time, cultural scholars are re-evaluating myth and memory, finding surprising consistencies across distant civilizations. Could the cosmic serpent be a meteor trail? Could the world tree be a symbolic axis for a sky once fractured by flame? More provocatively still, some suggest that the Earth, through its rhythms and feedbacks, operates as a form of cognition. Not in the way neurons fire, but in how balance is maintained, how disequilibrium is corrected. Lovelock's Gaia hypothesis, once fringe, now finds kinship in complexity theory and systems thinking. The planet, perhaps, is not alive in a biological sense, but in a systemic one. It behaves like something that learns, and that means our actions become inputs in that learning. Our emissions, our deforestation, our extraction, they are not isolated events, they are signals. The question, then, is not whether the Earth will respond, it will. The question is, will it remember us as part of the balance, or as the disturbance that had to be corrected? This is where the story of the Younger Dryas turns from paleohistory into parable. A final reflection stirs from its icy grave. Was it catastrophe, or was it clarity? Was the 1,000-year chill a punishment, or a pause? A reminder that Earth, though vast and ancient, is not infinite in patience. What we call disaster, nature may call recalibration. It is a sobering idea, but not without hope. Because memory, unlike prophecy, allows for choice. We are not doomed to repeat the rhythms of collapse. We are not trapped in some planetary metronome ticking toward the inevitable. If Earth remembers in ice, soil, and myth, then we, its most self-aware species, can remember too. And more than that, we can act. To act, though, is to feel. And to feel, we must first reawaken our own sense of time. Not the time of quarterly earnings, not the cycle of news or elections, but deep time. The time of rivers carving canyons, of glaciers grinding mountains, of stories sung over firelight for 10,000 years. Deep time humbles us, but it also situates us. We are not apart from Earth. We are an expression of it. We are what happens when carbon learns to speak, when water dreams, when clay rises and names the stars. And if that sounds poetic, it is. But it is also literally, geochemically, biologically true. The dust in our bones has been in stars and oceans and meteor trails. We are the planet remembering itself. The Younger Dryas, then, is not merely a frozen warning. It is a mirror. It shows us what happens when balance fails. But it also shows us that recovery is possible, that life returns, that memory endures. It teaches us that trauma can seed resilience, that civilizations can rise not in spite of hardship, but because of it. Göbekli Tepe stands not as a tombstone, but as a testimony. Not all scars are signs of defeat. Some are reminders of survival. And perhaps what those ancient builders tried to encode in stone, we now must encode in policy, in culture, in consciousness. Let us remember, not just the event, but the response. Let us remember how the planet speaks, quietly, patiently, clearly. Let us remember that the same earth which iced the mammoth and burned the sky also gave us wheat, rivers, and the songs that still linger in the hollows of old stone. And finally, let us remember that memory itself is a form of resilience. If the planet that remembers now whispers through its melting edges, through rising seas and burning forests, it is not yet shouting. It is giving us the last soft chance to listen. Let us listen. Let us remember. Thank you, fellow sapiens, for walking this long road through the ice and ash, tracing the arc of memory as it loops through stone, sky, and silence. If this story helped you feel the shape of deep time, glimpse the resilience within trauma, or sense the quiet wisdom held in myth and meltwater, then I'm grateful for your presence here. Perhaps a single image stayed with you, a temple buried to preserve its secret, or the echo of a fire in the sky that never fully faded. Whether it was the image of glaciers whispering their warnings, the quiet echo of a myth etched in stone, or the enduring sense of comet fire becoming legend, these fragments are what connect us, scattered across time but bound by shared wonder. If you feel called to, share that echo in the comments, not as noise but as a quiet offering. It's these little reflections that build our thoughtful community. If you'd like to wander further down these paths with us, you can like, subscribe, or simply return when the next strange story rises from the dark, because the planet still remembers, and so do we. Until then, stay curious, stay thoughtful,